right away. Okay. So I'm combining two topics. So I'll use the first 1.5 hours to cover the first one, and then the last 1.5 to complete the other one. So it should be done by around 8 p.m. hopefully. So I'm already back in school because I would have, I wanted to go and, I thought that because I'm still in town, there would be no need for me to go all the way to where I stay. I stay quite some distance away from the city center, and I thought just go back to school so that we can have this lecture because we can't afford right now to miss any class. So what we talk about today is the automotive electrical systems. So you already have the notes. I'm just going to go and just explain a few things here and there. So in automotive electrical systems, these are some of the systems in the vehicle that you would find I used, for example, to supply that is electrical energy to systems that require these kinds of, the required amount of electrical energy. And when you talk about the automotive electrical systems, it's so wide, by the way. It's very, very wide. I mean, when I know sometimes it sounds as simple as, for example, having a battery. The battery supplies electrical energy to power the infotainment system, to power the for example, maybe cameras. You have the camera modules, the cameras themselves, okay, like the reverse cameras, for instance, the headlights, the tail lights, etc., etc. But the automotive electrical system is bigger than that. It involves all electrical and electronic systems that are in the vehicle, and we are talking from things as simple and as small as sensors to actuators, to the electronic computer, the electronic control unit, etc. So it's very, very wide. It's very, very wide. And now, even with the advent of the EV systems, that is electric vehicles, the electric vehicles now have even much more advanced electrical systems than you would ever find in an ordinary ICE vehicle, that is internal combustion engine vehicle. For example, you find that in electrical system, in EVs, you'd find it has two parts of electrical systems. So we have one which we call the HV systems, that is high voltage systems. So high voltage is the power that comes from the battery. So the power that is supplied from the battery, for example, to operate the motor. The motor is a 3-phase motor. And you find that it's supplying, well, it depends on the size of the vehicle, but it could be supplying well over 400 volts or 800 volts, depending on the size of the vehicle. That's high voltage, direct current, okay? But you also have the low voltage side. For example, there is going to be an ordinary battery that would be used to provide 12 volts to operate things like, for example, we are talking about fuel pump, for instance. The fuel pump is not going to use 400 volts. It's not going to use 800 volts. So the fuel pump, or things like, for example, we're talking about even actuators. Okay, some sensors are sensors such as, for example, the thermocouples, the temperature sensors. Okay, the pressure differential sensors in the intake manifold, for instance, they sometimes use as low voltage as 5 volts. Okay, so which means that it will never, the high voltage side cannot be used to power the low voltage side. However, you can have a DC-DC converter where you sort of step down the voltage from as high as, say, 400 volts to 12 volts. And then that 12 volts can now be used to power the ordinary systems that you would have, for example, the radio, for instance. Okay, the radio in a car, okay, the cabin lights, they use very low voltage. And for example, if you also have systems that use like 5 voltage, sometimes they're just signal sensors. Those that put signals, for example, those that are connected to the, for example, the ECU, for instance. Okay, some of the circuits in the ECU require only maybe as low as 5 volts. So you'd have to require again another inverter, a DC-DC converter again to step it down all the way downwards to 5 volts. But even in an ordinary IC, you'd still require, for example, inverters. If you're talking about production of electrical energy, you know that the electrical energy in an ICE engine, an ICE vehicle, that is ordinary internal combustion engine vehicles, is supplied majorly by the battery. And where does the battery get its energy from? Okay, so the battery can be charged externally. You could take it to a charging station where you charge it to the required voltage, that is 12 volts. Maybe, for example, the capacity of the battery could be, say, 50 ampere hours. So you charge it to the required capacity, then it can be used. But as the vehicle operates, then you also need a way of regenerating power. And one way of the generating power in an engine is by simply using an alternator. An alternator runs on the power of the engine. So as the engine is operating, it is always converting energy, mechanical energy from the rotation of the engine, that is a crankshaft, always, and constantly converting it into electrical energy. So the alternator is a generator which converts mechanical energy from the rotating crankshaft and then is used to provide electrical energy that charges the battery. But again, it does not charge the battery directly. Okay, so lazima kukuwa na inverter kwa sababu the energy that is the electrical power that is produced by an alternator is AC. Okay, any kind of processes that convert mechanical energy into electrical energy always produce alternating current, never direct current. Now you will therefore need an AC-DC converter in order to change. So that one could be like, for example, a series of diodes. Okay, so you can have like an inverter icon, a series of diodes. You know how the function of diodes, which is going to do rectification. So you have what you would ordinarily call a rectifier, but it's just a series of diodes arranged in a certain way. So you have a rectification process that is going to convert the signal, the AC signal, which is usually a sine wave, into a direct current, which is usually just a straight line, and then it's now used to charge the battery. And then now the battery now provides, through regulators as well. We also have voltage regulators and all that can be able to control how much energy is required by the battery. The voltage that is required, and then it can now be used to supply to the electrical components that require to be powered. Now, sorry, I think this one I should have removed it, but we start here. So mnajua kuna different types of batteries. Kuna hizi conventional batteries. Conventional batteries ni zile tu za kawaida where it has they are called lead acid accumulators. You know how they function, the lead acid accumulators. So these ones you'd find them generally in a lot of common applications. Vehicles, you'd see them having this kind of lead acid accumulators, which simply use, so they have a cathode and an anode, and then they have lead, so they have anodes and cathodes, and then they in between is an electrolyte. Okay, so you have an electrolyte, which is usually some form of acid. I think it's hydrochloric acid, which is normally they have varying pH levels depending on the battery and the amount of energy that is required. And then it simply uses chemical reactions to produce electrical energy by simply having electrons shifting from anode to cathode. Then that stimulation of chemical reactions converts the chemical energy that is stored inside into electrical energy. And that electrical energy is usually just direct current. It does not alternate, it just comes out as direct current. Now, pia kuna zile zinaitwa special purpose batteries. Special purpose batteries ni zinatumikanga sana sana na hizi gari ziko na start stop. I don't know kama umeona those cars with start stop engines. So start stop engines are such that if you are if you are driving in na umeingia kwa traffic, then you find that these start stop systems they allow you, they switch off the engine automatically if the engine is in an idle position for, say, for example, 5 seconds or up to 10 seconds. Okay, so I don't know, I think it depends on the car and the calibration that is set in, but usually about 10 seconds. If the car is in idle position for like 10 seconds, or is it 5 seconds, then the car switches off because it realizes that you have stopped and you are not moving actively. Now, it is a very good thing for, it's very, very, it's a fuel efficient way of managing energy use in a vehicle, and it really minimizes the use of fuel, especially in scenarios where you are not moving. So how does it work? So generally, the start-stop system uses sensors, and these sensors are mostly the crankshaft position sensor, which you'll see that sometimes it uses derivatives, okay, which could controlled in which are contained in a controller. So this controller differentiates the position of the crankshaft. It will get its velocity, and then it can further differentiate it to get what? To get that is the angular acceleration. So by differentiating the position of the sensor, or maybe the position of the crankshaft, then it can also get its angular speed. So if the angular speed remains in an idle position, for example, most vehicles idle at, we call them idling speed. Idling speed is when the engine is running but it's not moving, and it's usually around 750 to 800 RPM, around there. So if it stays in an idle position, say for example 750 RPM for like 5 or 10 seconds, then it sends a signal to the ECU instructing it to switch off the engine. Okay, so that there is no, the engine is not running at all, but it does not switch off the electrical systems in the vehicle. So you'll still be able to listen to your radio, all right? However, the ECU will instruct, for example, actuators. For example, in an SI engine, it will instruct the throttle to go into a fully closed position so that there is no supply of air and fuel at all. Of course, in combination with other circuit systems, for example, the ignition system that supplies electrical energy to the ignition, the spark plug, for instance, all of those are switched off. Then the engine will not be operational. With an SI engine, if a spark ignition, is a compression ignition engine like diesel engine, then it shuts off supply of the fuel. Okay, it simply shuts off supply of the fuel, and the engine goes into an off position. So it will be switched off. So for that entire time, the engine is not running. And of course, usually, again, it also uses data from the brake pedal. So if the brake position sensor as well, the brake pedal position sensor shows that you have pressed your brake fully, and that the engine is in an idle state, then it switches off. So it will not switch off, because sometimes it could be the engine could be idling slightly, but maybe you've not pressed the brake fully, the brake pedal fully. So it will not switch off, because then it also looks at it as a dangerous scenario. If the engine is running and the engine is not, the brake is not fully engaged, then it can easily move. However, once you remove the brake pedal, then it will send a signal. Now, your signal in nanoseconds. The moment you remove your foot from the brake pedal, then you will see the engine switching off instantly. But that switching on and off requires a special purpose battery, so that these conventional batteries are not able to do the job. Okay. Now, disadvantages to these kinds of batteries, one of them is that, first of all, they are expensive. Hiyo ni kitu ya kwanza. Okay, these ones kama hii Amaron, utapata hii Bosch, so kwanza ziko expensive. Kama hii ingine saizi kwa market, I don't know how much, but I'm imagining anywhere between 8K na 10K unaweza pata a very good battery for your car. Same 50 ampere hours ama 45 ampere hours. Lakini hii ingine, prepare to part with from around 25K, 25K. Okay, that's almost 15,000 extra. So these special purpose batteries pia sio cheap people. Now, ukichukua hii special purpose, the conventional battery utumie kwa gari ya start stop. Hiyo start stop functionality haiwezi fanya. For example, kama gari yako iko na start stop functionality, that is, it will switch on and off when it's in idle state, say for example when you're in traffic. If your special purpose battery imeharibika, wewe ukaenda ukanunua ile ya kawaida chloride oxide, haiwezi kafanya. Why? Because it knows, because it will always take the special purpose battery is configured in such a way that with the moment it is connected to the terminals and they supplying the electrical energy, then the ECU is able to tell, it will always use the data in terms of voltage and current that is coming from that battery, and be able to tell that this battery is able to switch on the functionality of start stop. Now, that is a disadvantage moja, naweza sema tu ni expensive. Now, Ingine is that these batteries when they degrade, unajua batteries will degrade over time. Okay, let's say after 4 or 5 years imeanza, it's no longer the state of health, for example, imeanza kudegrade tu, haifanyi, it's one off nini, imekuwa imezeeka basically. So if it stops supplying the peak, I mean there's a nominal voltage for the start-stop system. If it stops supplying if the voltage supply is below the nominal, okay, then it will the ECU will disable the start-stop functionality yenyewe. So hii battery ikianza tu kukufa hivi, ikianza tu kuonyesha signs of failing, okay, the moment it starts showing signs of failing, then you will not access the start-stop functionality kwa engine yako, because the ECU is smart enough to know that if this battery imeanza kukufa, what if, for example, you are in traffic, it switches off normally, but kwa sababu battery imeisha ikashindwa kuiwasha gari, okay, it's unable to switch on the car. What happens? So it becomes a problem. Why? Because the engine is not, you are stuck in traffic and you are unable to start your car, okay, so you become an inconvenience on the road. Not only is it an inconvenience, it is also a safety issue. It's a safety concern. Inaweza gongwa. Okay, so that's the thing. So generally, when it starts failing, in a disable, and sometimes it even creates an error in the engine because it's not supplying the required amount of voltage. Say, for example, to the ECU. The ECU can identify that as an error. All right, it can identify that as a serious error. And you know what happens when the ECU senses that there is an error or there is a serious error, say that maybe the electrical power supply in the engine, that is the battery, is not supplying the right amount of voltage, say for example, to its sensors, to its actuators, etc., etc. Then engine itaona kama kuna gari imekufa. Okay, sometimes it misinterprets those, because if the sensor is not getting the required, the right voltage, then it can misinterpret certain information. Because remember, sensors gather information on so many things. For example, there's a pressure, temperature, etc., etc. So it can misinterpret certain things, which means it can tell or it can give faulty feedback to the ECU. So the ECU will think of, okay, there's some fault here. There's something that is wrong here. What do I do? Okay, so that fault or that error, the ECU can interpret it as a failure on all the components of the vehicle, but it's only being caused by a sensor that is not getting the right voltage, and it is already giving faulty or misleading data. So you might be surprised that the engine goes into what we call a limp mode. Limp mode is where the vehicle goes into what is called safe mode. So inakupatia only limited power. And when that situation happens where the vehicle goes into a limp mode, nakwambia unaweza kanyaga gari imefika 6000 RPM na haisongi. So it doesn't matter how fast the nini is rotating, how fast the crankshaft is rotating. It is not, it's not moving the car forward, all right? Because the car is in safe mode. So alafu, sometimes pia inakupatia, for example, these kinds of batteries, inaweza kukupatia, that kind of error signal can also cause your vehicle not to go into the second gear. Even if it's automatic, if it's manual transmission or automatic transmission. Sometimes you find, for example, especially in automatic transmissions, they normally just go in sequentially from the first gear, second, third, like that. So it will refuse to go, say, into the second gear. So itabaki tu kwa gear 1. So which means you cannot accelerate that car beyond a certain speed if it is in the first gear. Okay, so in a disable certain functionality, so you disadvantage here. You see, in the ordinary systems, it does not require instructions. The start-stop system does not, or the ECU does not require instructions on how to, but as long as it's getting some voltage, come a battery in a degrade, then it simply switches off. It can rely easily on the alternator to supply the remaining voltage. But most of these systems, new systems in vehicles are designed so that they do not over-depend on, say for example, the alternator if the battery is faulty position, or if it's degraded or faulty. So eventually you'll just have to replace it. So those are just some of the disadvantages in inakwanga nazo hizi batteries. Now, but of course they will always give you what I call very good fuel economy. Hiyo ndio uzuri ya these batteries. They'll always give you very good fuel economy. Now, the supply of energy in tulisema inatoka alternator. So alternator inakuanga na, so you can see here kuna kuanga na a pulley. Now that pulley is connected to another pulley that is normally found in the crankshaft. So in the crankshaft, okay. So in the crankshaft, and then you have the piston, and then at the end you normally have the flywheel. So this is the flywheel. Okay, the flywheel on that end. This is the pulley. So kwa engine tunakuanga na two parts, the pulley end and the and the flywheel end. So hapa utakuwa na inaitwaje, the pistons na nilikuwa nimesema kuna two at the top at any given time, in the middle like that, and then another one at the top. Okay, so as the crankshaft rotates, it simply taps the mechanical energy from the rotating crankshaft and it's used to power the alternator. So the alternator is just a generator, haina maneno mingi. Okay, and you can see there, and for example, you can see here that iko na pulley. So kama hii for example, iko na pulley. Okay, so this one is just like a part of a housing. Then here you can see the main rotating part ni ile rotor. Sasa hii rotor hii ndio, that is the one that actively now converts using the principle of electromagnetism. It simply converts mechanical energy into electrical energy using a combination of the rotor and the stator. And then here ukona, so inside here kuna kwanga na a rectifier. Na nimewambia rectifier kazi yake ni nini? The rectifier simply converts the AC current being produced into DC current. Now that DC current ndio inapeleka inakuwa stored by the battery. Okay, so that is the alternator. Now, so the other thing is, so the alternator is normally fixed just next to, not far from the engine. So it's usually not far from the engine, just almost next to the engine. And the reason is, you do not want to have, because if it is too far away from the engine, then you require a longer belt in order to connect the crankshaft and the pulley of the alternator. So if the belt is too long, then there will be added frictional losses. So to minimize losses, you will always find the alternator being fixed almost next to the engine. Now, so the parts of an alternator, nimesema kuna rotor. So rotor is the magnetic core that is rotating. That's a very a very important part. So it's a rotating magnet core that creates the magnetic field. So I'd advise you to maybe go and read in terms of how the rotating magnetic core generates a magnetic field, and that magnetic field creates what you call EMF, electromotive force. Okay, so that EMF, if there are two terminals or two parts that have varying voltages between the EMF that is being produced and the other side does not have or has a zero EMF, then we say in that case there's what you call a potential difference. So that voltage will flow from a part where there is high EMF to the part where there is no EMF. Okay, so it becomes something, some sort of a force. Because voltage is something like a force that drags current alongside it. Okay, so when the voltage crosses or it moves, the potential, if it's trying to, that electromotive force tries to bridge two parts that have different potential differences, then we say there is voltage in that circuit. Okay, so that's how generally electrical machines transfer voltage, and of course they always go alongside the current. So pia kuna stator. Stator is a stationary set of wire windings, na I think ndio hii nilikuwa ndio hii, so iko hapa ndani. So the stator iko hapa ndani. You can see these are the coils, the wire windings. So that is what you call the stator. So the stator simply generates now the alternating current itself. So the rotor is the one that rotates. Okay, it's part of the, connected directly to the pulley, and then the stator is inside it. So when there's a part that is rotating and the stator is stationary relative to the rotating rotor, then, and in fact the names are usually directly gotten from because of their functionality. So the rotor is something that is rotating, stator is static. Okay, it's stationary, it's not moving at all. So the combination of those two is how electric current is generated. Now we also have the slip rings and the brushes. So the slip rings provide continuous electrical connections to the rotor windings. So slip rings generally, slip rings are the ones that now cuts the voltage on and off, because lazima polarities inakuwa changed. You know how an how it functions is like that on one end there is a north pole, so the other part you also have to create a north pole so that there is a repulsion. So like that now the stator must have a north pole, and the magnet, which is the rotor, also has a north pole. In that case, they repel each other. In repelling, it's in a skuma, the stator away, because it's pushing it. Now, you have to change polarity so that it attracts the lower part. So it pushes one part away and attracts the lower part. As it attracts the lower part, by the time inafika hapa juu, you have to switch polarity now so that it goes north and north, so that it repels. So that attraction and repulsion is the one that causes a rotating, the rotation of the rotation of the rotor, okay, because of the magnetic field. So that constant change in polarity, so that you attract, repel, and then in the end you have a circular motion, is normally caused by the slip rings, okay. So that if you have so many of them, then you have like a continuous supply. So even if it is an AC current, you have the phasing between the current that is being produced being so close to each other, so that you feel like it's a continuous supply of current, even if there are some sections where there is no supply of current, because when you switch polarity, you also cut off the supply of the current, okay. But now because of the way the stator is normally designed, is say that it's very hard to notice the change, okay, that there's some sections where the current is off. So basically AC inakuangani, it's an on and off signal, on off signal. That's how it's produced. Now voltage regulator na control ile output ya alternator. Unajua hii alternator, if it's not control, there's no control, sometimes it can oversupply voltage. So unaweza pata kwa voltage yenye inaingia pale kwa alternator, inaenda kwa battery is too much. For example, unaweza pata alternator ina supply 16 volts or 20 volts. Na battery inahitaji only a maximum of 14.5 volts. Nominal inakuwa 12 volts. But when it's charging, that is when the alternator is moving. Ukiswitch on gari, we say that the battery is in a charging condition. So inaendanga hadi kitu kama 14 ama 14.5. Okay? But ikipita hapo, itakuwa overcharge. Na overcharge, it will create a disturbance in terms of the electrical processes that are happening. Because remember, charging the opposite of discharging. Okay? So it means the chemical processes that happen during discharging occur opposite during charging. So it means that it could easily end up degrading the battery very fast. So voltage regulator lazima ikue in order to stabilize the voltage supply to the battery. So usually inakuwa around 13.5 to 14.5. Okay? Now rectifier nimesema, rectifier ni diodes. Unajua kazi ya diodes, they simply convert AC into DC. Pulley is the one that is mounted on the alternator shaft, and then it's driven by a serpentine or V-belt from the engine to spin the rotor. Cooling fan, unajua hii kitu ina hit sana. I think nyinyi mnajua any part mahali tu kuna current being generated or current being transmitted, those electrical connections always hit up. You know why? Because the process of transmitting electricity in form, if you now talk about current, for instance, you know, current is simply all about vibration of the energy fields within a conductor. Okay? If I might dump it down, we could think of what we call electrons. Okay? The vibration of electrons. They don't move, but they sort of vibrate and then they transfer them. I think you know the mechanism in which current is transferred. So the excitement of the electrical, the energy fields within conductors is usually raises energy levels in a conductor. So anytime there's a potential difference being bridged, okay, there's voltage traveling, it drags current with it. Then energy levels inside, in the localized energy fields within the conductors usually raise the kinetic activity. Okay, So if there's a high kinetic activity inside, then there will also be a raise in temperature. So generally where there is a lot of excitement, okay, excited electrons, then it raises the energy levels, which means that it also raises the temperature. So huwa zina heat up. That's why hata ukishika charge yako saa zile una charge maybe simu, ukishika especially pale kunakuwa na ka small transformer pale, it's just a coil, something that has, I mean a core that has primary and secondary windings. So in the process of electromagnetic induction that happens there is usually production of heat energy. So ukisikia utasikia tu iko moto, hata ile waya tu ya kucharge laptop unasikianga tu iko moto because of that. Okay, so which means that also these alternator lazima inakuwa cooled down, so it must be cooled down, lazima ikuwe cooled down because it will always be very very hot all the time. Okay, now pia kuna casing sana sana inakuwa na vents in order to aid the process of cooling, na pia kuna aluminum or metal shells that hold the components together. And why is it aluminum? So that it is light. So you always want the components to be as light as possible. So alternator ni kitu inakuanga light sana, if you've seen, especially for the ordinary vehicles, unapata tu alternator inakuanga ni kitu ingine very very light. Okay, so kuna pia kitu inaitwa ignition coil. Ignition coil ni hii. So ignition coil basically for that, ignition coil is where there are primary and secondary windings that cause electromagnetic induction, so that it's found is part of what we call the ignition system. So kuna kitu inaitwa ignition system in a vehicle. So I wanted to differentiate between ignition system and a starting system. Starting system is when you are starting the vehicle. So you are starting a vehicle, and then you find that the starting system is the one that cranks the crankshaft. We call it cranking. Now, how exactly does it function? So if you are switching on your vehicle and gari ilikuwa imezima, then a high amount of energy is usually sent from the battery to what we call a starter motor. So the starter motor usually runs, it works opposite to the generator. Now it becomes a motor. Okay, so in this case now you have electrical energy producing mechanical energy. It's now the opposite of the generator, that is the alternator, which converts mechanical into electrical energy. Now this one converts mechanical energy into electrical energy, and then it runs a pinion gear that usually rotates the flywheel, and when the flywheel is rotated, it rotates the crankshaft. All right, so that is the static system. Like in ignition system is the system that supplies electrical voltage to the spark plugs when the engine is operating. Okay, so usually one of the primary things in a conga this ignition coil. Okay, that is the ignition coil. I'm going to explain something else, and then I'm going just to explain it more. So this is a working principle of ignition coil. So first of all, this is the one. Wacha tu niende hapa kwanza alafu nitawaelezea. So this is in your starting system. Okay, before I go to ignition system. So this is the starting system. So kwa starting system unafaa ujue kitu kimoja. So hii hapa kuna crankshaft connected to, okay, na hii sprocket camshaft. Okay, that is a camshaft. Now the camshaft, you can see here that you have the pistons. Okay, the pistons. All these are the pistons. So the rotation of the crankshaft it occurs because of the combustion process. Okay, power stroke. Now, lakini saa zile unaanzisha gari, there is no combustion taking place. So what you would normally do ordinarily is that the battery, your battery, is connected to the starter motor. Now this is the starter motor. Okay, hii ndio starter motor. So hiyo starter motor contains a pinion gear. Sorry, somebody called me. So now I was saying that the starter motor has one primary thing which I'm just going to talk about here. There is a pinion gear. It's a gear. Okay, it's a gear. Now, this is the flywheel. The flywheel also has teeth. Okay, so the pinion has teeth, while the gear, the flywheel, the edges of the flywheel also has some teeth. So if you see, I don't know whether it was this one. I don't know. It's like I didn't. Actually thought it was this one. Maybe it's another one. But generally, all I'm saying is this: that this gear here, when you switch on your car, I don't know. I'll explain this. Probably it's in another slide. I'm not very sure. But when you switch on your car, there's a mechanism that pushes this pinion gear outward, so that in a mesh nahi, the flywheel. That is the first thing. It's not rotating. It is simply being pushed outward. Now, once it's pushed outward and it has meshed with the flywheel properly, because nimesema both ziko na teeth, once they have meshed properly, then it completes another circuit inside the starter motor that now connects it now to the battery. So battery is now able to supply energy. And then it rotates the pinion gear at a very high speed. Okay, so there's a mechanism that rotates it at a very high speed. Because the pinion gear at this stage is fully meshed to the crankshaft, then the crankshaft will rotate. And you can see here, this is the starter motor. So the crankshaft rotates. Now when the crankshaft rotates, you know what will happen. The pistons will move back and forth. Kama hizi ziko juu zitakuja chini, these ones zitaenda juu. So one of them will get what you call the power stroke. So moja itashika, it will start with the power stroke. Now, once it gets power stroke, there's another one also, because of the way they are faced, because of the firing order. A neighboring one will also go through a combustion process. Now, remember, the series of combustion process continually produce mechanical energy until that mechanical energy is sufficient enough to run the flywheel by themselves. So there will be a continuous change between kinetic energy produced during power stroke or during the combustion process and the potential energy from the flywheel being supplied back to run the flywheels, the crankshaft, when it is in exhaust, compression, and intake. Okay, so that is what usually happens. So what I have said is this: that the flywheel, so here the pinion gear, first of all, has to engage na hii. Haiwezi kuwa ina rotate kwanza, it must engage. And if it does not engage properly, then the gear, the circuit inside the starter motor will not be complete. So inamaanisha hiyo gari haiwezi kawaka, because if those teeth do not mesh properly, yes, if they do not mesh properly, for instance, then there would usually be there usually be a clash between the teeth. So it means that if it were even to rotate, they will wear each other, because they'll be moving relative to each other, but not together at the same rate. Okay, so therefore they must mesh, and most of the cases they'll mesh properly. Why? Because there's also a mechanism that pushes the starter motor. So as the starter motor sazile inatoka nje, sazile it's being pushed outward. When you turn on the ignition key, it does not come straight. It usually comes out as if it is rotating slightly. So that slight rotation of the pinion gear as it is coming outward to mesh with the teeth of the flywheel, itakuwa inatafuta tu mahali zinaweza mesh. It's basically a way of looking for a proper mesh. But unajua ikikuja straight, sometimes the teeth of the flywheel and the pinion clash. So there'll be nothing. Haiwezi ukawasha hiyo gari. But because they would usually be rotating, somehow kuna vile zita mesh. The moment they mesh, they complete the circuit, then it rotates. Na hivyo ndio unawasha gari. Okay? Na that's why ukionanga zile manual cars za kitambo, ulikuwa unaweza ku rotate. Unaweza push gari kama unataka kuiwasha, tuseme battery imeisha. Why? Kwa sababu this flywheel here, okay, on this side kuna engine, but on the other side hapa it's connected to the gearbox, and from the gearbox the drive shaft. So uko na mguu hapa, so ukisukuma hiyo gari huo unasukuma, you are not doing the opposite, you are using the wheels to rotate the flywheel. Okay, in ordinarily the crankshaft rotates the flywheel and then the power goes to the wheels, but in this case ulikuwa unasukumanga gari so that you have the pistons moving up and down, at least one of them will achieve power stroke, and then unapata gari imewaka. But you cannot do that with automatic transmission vehicles kwa sababu hapa kwa hizo zingine kulikuwa na clutch hapa, so you could easily fully separate the power transfer in the powertrain by pressing on the clutch, but you cannot do that with automatic transmissions, it's not possible. Okay, so lazima tuta jumpstart gari in case iko na shida. Okay, lazima tuita jumpstart gari, na huko jumpstart gari inahitaji a battery where you will connect the one that is functioning. So kutakuwa na positive and negative terminal for the one that is working, you connect it to the positive and negative terminal for the one that is not functional. Okay, so you would usually connect this and this, and then unawasha gari. So this is the functional battery, this is the dead battery. Okay, so you just connect it positive to positive, negative to negative. However, siku hizi kuna power banks, sijui kama umeziona, kuna kwanga na power banks ambazo zinatumika ku jumpstart gari. So unapata ni power bank iko na battery, I mean capacity, so they are just lithium ion phosphate batteries, but iko na capacity up to about 12,000 milliampere hours. It can supply a lot of electric current, 12,000 milliampere hours. Yeah, na ni portable, ni power bank tu kama kawaida, ile tu kama power bank ya kawaida, na iko na positive and negative terminals. Okay, so you connect it and then una connect to positive and negative terminals to a vehicle. Okay, ya battery, na unawasha gari kama kawaida, so inakusaving the kind of inconvenience. You sometimes unaweza kuwa maybe ulienda ukapark gari mahali ukasema hey, acha nikunywe chai or something like that, kukuja unapata gari imezima. Okay, or maybe you are going on a long journey, maybe battery kabisa imeharibika. Unajua kuna zingine imeharibika kabisa yenye ukizima tu gari kidogo ina drain very fast na imeisha kwa sababu battery is really dead. Or maybe you simply went and packed it kwa mtu uka-attend mkutano 6 hours, by the time unarudi battery imeisha, na labda wewe peke yako ndio ulikuwa na gari kwa hiyo function. What will you do? Sasa kwenda kutafuta gari nyingine karibu, labda mwende uko njia utafute boda, uende utafute gari ikuje ikuashie nini, ama uache gari mpaka kesho yake, ama uende utafute battery kwingine. So to avoid that, you could easily just buy that. So I have one myself and it is very nice, it's very portable. I carry it around just for emergencies. But I've also found myself also helping people on the road on 3 or 4 occasions. So yeah, I'm going on the highway, it's mchana around 3 p.m. and then mtu anakusimamisha, unaona tu ameweka gari huko kando. Ukiona tu anasimamisha inamaanisha kuna usaidizi anataka. Ukipark gari mtu anakuambia battery imeisha, kuja pindua gari ukuje unifanyie, unijumpstartie. Mimi namwambia hold your horses, ama inasemanga hold my beer, I don't know which is the phrase. And then mimi natokelezea tu na mkono, I mean nakuja tu na kitu nimeshika kwa mkono. Na nikamwambia wewe kuja, nimekwambia kuja na gari ni washi, namwambia relax. Fungua gari, ninaekelea hapo kidude, namwambia washa. Gari inawaka, mimi naenda zangu. Namwacha akishangaa. Hii ni teknolojia gani tena hii? Okay, I don't know whether I'm still I think niko na issue na internet sometimes. I don't know whether I'm still audible. or whether somebody can confirm it by just typing in the public chat that you can hear me. Okay, so anyway, so I was saying that having the portable one huwa inaokoleanga sana, because sometimes you find yourself in a situation where you are in the village. Could somebody just confirm that you can hear me? Anybody tu hapo kwa public chat, just confirm. Okay, thank you. So now, so I'm saying that sometimes having it as a form of emergency is very important, because sometimes it's not that your battery is faulty. Sometimes kunatokelezea tu some incidents zenye unasema it's good I had it. For example, I remember one of the times I was there somewhere in the village attending a function, then somebody asked me, nimechoka, so nipatie kifunguo niende tu nikae kwa gari hapo. Yeye amefika kwa gari akaamua kusikiza muziki. Na amesikia ngoma zake, hajawasha gari. Kuna vile you can always just switch on the infotainment system without basically switching on the engine. You can just access the infotainment system without switching on the engine. So mtu ameanza kusikiza ngoma zake hapo. Alafu vile after some time mimi akafunga gari na akakuja. Mimi sasa kurudi tunataka kwenda na washa gari imekataa. Shangaa, how is it and this battery is still relatively new. Jamaa kaningoni jeli kuja nikasema nisikize muziki hapa na pale, hapo sasa ikakuwa ni ngori. So long story short, I had a backup. Tukawasha tu gari na tukaenda. But I'm trying to imagine a situation where, for example, you are far away from, sometimes you are in a very remote place. So hapo kwanza ingebidi tutafute mahali pa kulala, maybe there was no position for accommodation, something like that. Or you start looking for somebody who could be a little bit further away, akuja akuwashe gari and all that. And these automatic transmission vehicles you cannot jumpstart. I mean, you can't huwezi ukasukuma gari. So anyway, all I'm saying is this, that sometimes it's important to have those kinds of contingencies, especially if you have a car. Now, again, I just want to mention something here. So this is the ignition system, the conventional ignition system inakaa tu hivi. So nilikuwa nimesema battery here, there's a battery here that supplies electrical energy, and then you have the ignition coil. So what is the work of the ignition coil? Like I said, the ignition coil, its work is to do what? So it has primary and secondary windings, ndio hizi, wound over an iron core. It steps up the battery voltage from 12 volts to 10,000 volts. So the coil does the opposite of an inverter. Okay, so you have an inverter or a rectifier or an inverter assembly that can step down voltage. Okay, so this one steps up the voltage from 12 volts to as high as 10,000 volts through electromagnetic induction. So in electromagnetic induction, you have the iron core like that, and then hapo kuna secondary windings, and then on the other side kuna secondary winding. Hizi zinaenda hivi na hii inaenda hivi. So which means there is no direct contact between the primary windings and the secondary windings. Hivyo. So this is the secondary windings. So here uko na 12 volts. And then hapa una produce 10,000 volts. Okay? So that 10,000 volts now is the one that will now cause the ignition process to start. Now kitu kingine hapo unafaa kujua ni hii. The ignition from the ignition coil. Okay, kuna kitu inaitwa contact breaker. We'll talk about it in just one while, and a capacitor. Okay, tutaongelea those two in just one while. So generally uko na distributor. What is the work of a distributor? So this distributor has an arm. Can you see this arm? This one here. So that arm rotates, and you can see here, hii ni 1, hii ni 3, hii ni 4, hii ni 2. Na hiyo ni nini? Ukiona hiyo, that is what you call the firing order. Alright? So the battery supplies energy through the ignition coil and then the distributor alternately. So kazi ya distributor is, for example, in this one, the one that is contacted there is cylinder number 1. Hii ni cylinder number 1, this is cylinder number 2, this is cylinder number 3, this is cylinder number 4. So utapata ita contact cylinder number 1, first one. And then the next one to be contacted itakuwa ni gani? Cylinder number 3. And then it goes to cylinder number 4 and then cylinder number 2. Like that, and then inaenda 1 3 4 2 1 2 1 3 4 2 1 3 4 2, like that. So it according to the firing order. Now usually the distributor is operated by the rotating cam. So camshaft, so there's a cam that operates the distributor, and it will operate it according to the firing order, because the rotation of the crankshaft and the rotation of the camshaft have to be synchronized. Why? Because the crankshaft operates the movement of the pistons up and down, while the camshaft cooperates the opening and closing of the valves. And this distributor is the one that is in charge of ensuring that the right cylinder fires at the right time. Okay? So the conventional ignition system inakaa hivyo. So I just wanted you to differentiate between an ignition. Sometimes I have seen some students confuse between an ignition system and a starting system. Okay? Starting system is different. So starting system is the one that is, it's a part of an electrical circuit system, okay? And I mean, it's part of the electrical, the starting system. But so, mostly, kuna certain parts of the circuit that they will share, okay? Kuna certain parts of the circuits ambazo zita share, okay? For example, there is a safety switch that is normally incorporated into the circuit, okay? Kuna kuanga na a safety switch. So kama hii, for example, you can see that there is an ignition switch hapa, okay? So I know this diagram haionyeshi, but usually, sometimes kuna kuanga na a safety switch just before the ignition coil. So that safety switch is normally included there, for example, to prevent either the ignition system or the starting system from operating if, for example, the vehicle is in a parked, in a drive position. Unaweza kwa, for example, maybe huko umetoa gears, if it's a manual, ni kuna kwa nile kitu tunasema unatoa gears, either move it to neutral position or park position. Okay? So if it's in gear, say for example gear 1 is engaged, huwezi ukawashia gari. So it will not allow the safety switch is like that, because imagine if you switch on the car, gari inaweza, if it starts operating and it's already in gear, inamaanisha it will jerk forward. Right? So it's not supposed to be, it's not supposed to went that way. So, and in fact, you'll find that for you to have the safety switch off, in so quite a number of cars, you have to press the brake pedal, because it's also a safety thing to press the brake pedal, so that in case for some reason, bahati mbaya tu hivi, the gear is engaged, any gear is engaged kwa gearbox, gari hata haiwezi enda mahali. Okay? But if it is not off, kama hiyo gari haiko off, sorry, kama for example you've not pressed the accelerator, the brake pedal, na uwashe hiyo gari, itawasha tu infotainment system, itakuwasha tu dashboard lights na nini vitu kama hizo. Okay? Ama radio, but haiwezi ikawasha engine. So it's just part of, so kunakuwa na safety switches. Also as part of this circuit system, either on the ignition but especially the starting system, pia part of the circuitry ya starting system unapatanga ndio wanaika ile kitu wanaitanga cutout, kama umesikianga cutout. So cutout is just a special switch ambayo inaikuwa as part of the starting system, so that uwezi ukawasha hiyo gari if, for example, you have not completed that circuit, because in a cut-off circuit, so they'll just cut it out in any part. So tunaitanga cutout kwa sababu it isolates part of the circuit network. Okay? Part of the circuit will be open as long as the circuit is not complete at the switch. So because a cutout is just a switch. So utapata lazima unafinya hiyo switch kwanza to complete the circuit, because it's usually a type of a switch inaitwa, I've forgotten the name of this switch. The kind of switch that, it's like an on-off switch. Okay, in one position it will complete the circuit, in an opposite position it opens the circuit. So when the circuit is open, huwezi ukawasha hiyo gari. So kama ujui mahali cutout iko, so just a safety thing, just a safety thing. So part of the cutout inakuwa kwa starting system. Okay, inakwenda pale kwa starting system. Now some other advanced features also utapata kuna certain also immobilizers that are normally also placed in the ignition system. Okay, so utapata yes, unaweza unawasha gari but after some time unapata the ignition system fails to work, so you gari tazima tu. Okay, so kuna certain types of immobilizers ziko mingi sana these days. You'll find some certain types of immobilizers that will also open the circuit at random points along the ignition system or the starting system, and it's usually just a feature. For example, utazipata kwa hao watu wenye operate hizi fleets kama maybe hizi za umepea mtu afanye Uber nayo, na maybe huyo mtu hajarimit pesa, so una switch off the engine. So those kinds of remote immobilizers could also just be playing around with the circuit systems in ignition or starting system, but mostly they are placed in the starting system. Okay, but there are so many types of immobilizers. I'm just saying some of them usually target the starting system. So napata wezi washa gari. Okay, so ni mpaka yeye mwenyewe afungue remotely, so they simply send a signal remotely through the GPS system to the ECU to allow the connection to happen. Okay, so they usually exist zinakuanga hata hizi EVs, most of them the EVs siku hizi ziko nazo especially but now for the EVs you see that there's a difference. For the EVs it's a certain kind of, I mean a different kind of what I'd call scenario, because usually for EVs, for example, if you have vehicles kama Basigo for instance, unajua kampuni kama gani Super Metro ama City Hopper ikinunua gari kama ya Basigo, battery bado inabaki ni ya Basigo. Bus ni yako, the shell and the chassis, but battery ni ya Basigo, so lazima wa monitor. Okay, they always have to monitor. All right, so they can always do anything to that vehicle. They could easily even send a signal to the battery management system to isolate the contactor so that huwezi pata power. So I'm just saying that so they just operates almost the same way, but it's almost a very similar idea of simply isolating part of the circuit systems in order to ensure that there's no power being supplied, say for example to the engine if it is an ICE. So that is a conventional ignition system. Now let's go to the ignition coil also. So because I just wanted to go there. So kwa ignition coil, so working principle is that an ignition coil is made up of a layered core, iron core surrounded by two copper coils. So it's different from a power transformer in that there is an open magnetic circuit. The energy is collected in the core and is the same energy that is given to the spark plug. Primary windings has lesser but heavy wire turns, while secondary winding has many turns but made up of smaller wire diameter. The enamel and layers of oiled paper insulation insulate the windings from the high voltage. The coil is fitted into a metallic can with high voltage and insulated terminals of low voltage connections. So now the most important thing to understand is the contact breaker. So when the contact breaker is off, okay, it's off, it permits current to flow through the primary windings. So the flow of current is not so quick because of what you call inductance. So then the next thing is this: the current must flow for the time to store sufficient energy in the field for the striking spark. Once the current is its full capacity, the contact breaker turns on. Okay, so basically the way it functions is that the contact breaker, which is this one, so contact breaker ni hii, so it simply goes on and off. So when it is on, it allows the energy through the primary windings. Okay, that is voltage through the primary windings, so the current. When it switches off, because it goes into an on and off position, there is a sudden collapse in magnetic field. That sudden collapse in magnetic field induces current in the secondary side, and the voltage is way higher than what was initially there in the primary windings. So it simply builds on and off. Now, kazi ya capacitor hapa ni nini? The capacitor is to store that charge for the next cycle. Basically, just stores the charge for the next cycle, and then after the rapid collapse of the magnetic field and the current is induced in the secondary windings, it turns on again and then allows the primary windings again to have some current. Okay, so it simply functions that way, rotating. It's very easy to understand. You could check your notes. I've explained it very well. And that is how it functions. Okay, so that's how it functions. Now, as ignition coils, kuna kunga na certain problems that it might have. For example, backfiring. So backfiring is where, for example, you have so backfiring is, for example, where you have an issue to do with how do I explain this? It's like misfire of the engine. So ikiwa na misfiring of the engine, a misfire means if the ignition coil, for example, is worn out, and it can be worn out in a number of ways. One, if the voltage regulator in the battery, because in a small voltage regulator there also that prevents excessive supply of current to the primary windings, and sometimes you know that it behaves as a transformer. So some of the problems here are transformers. If you remember from, I don't know whether you've done them in electrical machines, kuna kitu inaitwa eddy currents na zingine inaitwa hysteresis. So those two problems can cause what we call arcing. Arcing is where in the process of transfer of electrical current from primary to secondary side, sometimes kuna arcing. Arcing means it's like some static electricity. Okay, it's like some static electricity being created there. If the arcing is too high, then it, because of maybe an oversupply of voltage, say for example from the primary side, then that arcing can easily destroy the magnetic core. Okay, so it can overheat the magnetic core. If the magnetic core is not functional, then the coil will not function as intended, because it really relies on the magnetic core for it to function as intended. So inamaanisha, at some point, it's not providing a continuous supply of electric current to the secondary side and to the spark plugs. So utapata in that point when it's not supplying, then the spark plugs is not functioning. Kwa sababu gani? It's not receiving any electrical energy. So if there is no electrical energy in the spark plugs and it is time for that specific spark plug to fire, it will not fire. Now, when it fails to fire, it means that there will be no combustion process in that cylinder. All right? So, now, in that process, inaleta an issue to do with pure fuel economy. Because inamaanisha, fuel is being supplied to the engine, to the cylinder rather, but it's not being combusted. So itatoka tu as exhaust products without being combusted. So inamaanisha, there is no energy moving. The energy that would have been produced to move the vehicle forward is not being produced. So unapata kuna hiyo poor fuel economy. Okay? Because ni kama kuleak fuel basically. There's also vehicle stalling. Vehicle stalling is where you are, the vehicle is rotating, the crankshaft is rotating, but it's not moving the car forward. So tunasema hiyo gari imestall. Okay? So it's not moving the car forward. So it stalls, and it can stall if there is no sufficient production of power in the engine because of an ignition coil problem. Now, as ignition coils, it's very easy to know sometimes that there is a fault, because sometimes you will see an electrical arc. Kujua ignition coil in a come, for example, kama hii. Okay, this one you can use this one. Sometimes unapata along hapa, unaona something that looks like an arc. Sometimes it's very easy to know, even by just looking at it with the naked eye. If there is a damage to the ignition coil, most of the time you'll see something like an arc running along the length hapa, physically. Because you know from here is where you have the spark plugs. Eh? Yeah, so that is from where you have the spark plugs. Okay, so now, so that is what I mean. So from where you have the spark plugs, because hapo utapata kuna, what is happening here? Yes, so here you'd have your spark plugs. Okay, so one of the ways to know whether or not it's still functional is also to check physically, because sometimes you find that if one of them has a fault, then it will also cause a lot of misfiring in the engine. Okay, and you will not have uniform production of power. So inamaanisha one of the cylinder is producing power, the next cycle is not producing any power. So that uneven production of power will now cause the engine to start vibrating. So it can also cause issues to do, like, for example, engine vibration. Okay, you have like engine vibration. And why is engine vibration very a thing? It is because along the crankshaft, lazima kuna produce power and distributing it along the crankshaft. Okay, that's why we have what we call the firing order, if you remember. But if, for example, one of the cylinders is misfiring, then inaleta this kind of problem that you are seeing here. Okay, engine jacking and rough idling. Now, what is rough idling? Rough idling, nilikuwa nimewaambia that idling ya magari mingi usually uko around 750 to maybe 900 RPM. Now, rough idling is where you have the engine, if you are not operating the vehicle in any way, gari haisongi. Umeweka tu in the idle mode, maybe umewasha na hujasonga. Okay, umewasha ukaeka parking. Okay, ama umewasha gari, but maybe you're still checking a few things before you move. The vehicle usually goes into idle mode or an idle state. So at that time, it's rotating around 750 to 900 RPM. Now with rough idling, when there's a a problem with the spark plugs, unapata the engine is at one point inaenda to 600 RPM, and at that point inaenda to 1200 RPM because of uneven power production. So which means at one point some of the cylinders are not firing. So you get a very low RPM in idle state, say for example around 650. In the next minute, all the cylinders suddenly fire. So it injects sudden power in the engine. That sudden power in the engine, it a push revving or the RPM of the engine to kitu kama 1000 or 1200. And then tena inarudi chini. So that variation, okay, generally, hata when the car is in a stationary state and the engine is on and it's idling, even the idling is not usually constant sometimes, but the range, usually the difference in range is not usually more than 50 RPM for a well-maintained vehicle. So utapata maybe between 700 and 750, haiendi hapo. But if it is varying from 600 to 1000 RPM, inarudi tena chini to 800 and 1200, that is what you call rough idling. And it is caused by poor power production because of worn out ignition coils. Okay? And it can also be caused by worn out spark plugs. Now the engine can also fail to start. For example, if the engine is not firing at all, especially for spark ignition engines, then haiwezi kafanya. Then those are some of the things. So if you're also having a problem with the engine not starting, those are some of the symptoms of these kinds of problems. There's also poor acceleration and loss of power. So when the ignition coil is worn out, okay, totally worn out, for instance, utapata there's poor acceleration, because if you are attempting to accelerate and some of the cylinders are not firing properly, maybe only one cylinder is firing out of 4 cylinders, because 3 of them could be gone kabisa. So utapata unakanya gari lakini haiendi because only one cylinder is producing power. You always you can accelerate. That is now the situation where we call engine stalling. So engine can stall. Now engine control unit can also shift into what you call home or limp mode. Ile nilikuwa nawaambia, unakanyaga gari ina rev all the way to 600 RPM but haiendi mbele. So that is what you call a safe mode. So it goes into a limp mode if, for example, the ignition coils are not functioning properly or the spark plugs are also worn out. Now, pia utaona pia engine fault codes, engine check light, it could also tell you that there is also a problem. Okay. Now, so those are the ignition coil problems. So, kuna different types of ignition systems. So, kuna ile conventional. So, conventional is the ordinary. Hii ambayo tumeongelea. We just talked about it right now. So, nilikuwa nimesema that here, the contact opens and closes using the camshaft rotation. The capacitor is connected and stores the energy induced to primary windings when the circuit becomes open. One end of the secondary coil is connected to the contact breaker, while the other end is connected to the distributor. The rotating switch of the distributor distributes high voltage to the different spark plugs according to their firing order. Basically, hakuna kitu ngumu. Magneto ignition system ni zile utapata na you'll find that there is no battery in the magneto coil ignition systems, by the way. So here, the rotating magnet here, okay, produces that is electrical energy that is supplied to the spark plugs, basically. So you can see that it works on the principle of electromagnetic induction. So a rotating magnet near a coil of wire generates electricity. So this one has no battery. That is the advantage. Na hii utapata sana sana kwa two-stroke engines that are very light. Those very light two-stroke engines utapata zinatumia this magneto-coil ignition system, kwa sababu sasa kama ile lawnmower ama the handheld lawnmower for example, or handheld drills, zile ambazo zinatumia zile zinatumika kwa remote areas, haiwezi kuwa na battery. Okay, so inatumia the magneto-coil ignition system. So the rotating armature, okay, the rotating magnet simply produces electric currents using the principle of electromagnetic induction. So that rotation here induces current on the secondary windings. Okay, and then now it supplies that to the distributor, and you can see the distributor distributes to the spark plugs. Okay, pia iko na contact breaker, na nimesema contact breaker kazi yake ni on off, so that there's a build up of current on the primary side, and then it collapses very rapidly, causing an induction of current in the secondary side. Okay, and now it's operated by the cam. So you can see the contact breaker is operated by the rotating cam. Now, so the other thing is so here nimeeleza pia vizuri. You can see here that the sudden opening causes a rapid collapse of magnetic field in the coil. The capacitor absorbs the voltage spike, preventing arcing the breaker points and aiding rapid field collapse. So ujue, when there is a collapse of electric, of the voltage, okay, when there is collapse of the voltage, when the circuit become open in the primary side, then usually the voltage takes time kurudi very quickly. So lazima ukuwe na capacitor to absorb the extra charges. Okay, lazima una absorb hizo extra charges so that it prevents arcing. Arcing is where you move voltage from very high voltage to very low voltage at a very short time. So usually inaoleta hiyo arcing. Think of arcing as, for example, kama zile kuna ile inaitangwa nini, arc welding. So mnajonga kwa arc welding, unakonga na the welding rod and then the metal itself. So for you to weld it, unaikaribisha this metal electrode to the workpiece. Ikikaribianga kuna kuanga na unaona kuna kuwa na that arcing between them. So unapata there is like some static electricity, because unapata it's attempting to jump that gap. So in the attempt to jump that gap, because of the voltage or the potential difference created between the metal and the electrode, then inaletanga a problem to do with arcing. So arcing ni ile produces sparks, basically. That's what I mean. So to prevent that, usually uko na capacitor to absorb the extra voltage when the field is collapsing, because it is that collapse of the field on the primary side or the magnetic field on the primary side that aids or that induces voltage in the secondary side. Okay, so the high voltage is sent to the spark plug, generating a spark that ignites the air fuel mixture. So it's very easy. Hakuna kitu ngumu. Kuna electronic ignition, by the way. So electronic ignition system unapata. Now this one here. So here there's an ignition coil. Okay. But now, so you also have a distributor, right? So kuna distributor. So, but now the control of which spark plug gets the energy at what point is controlled directly by the ECU. So ECU inafanyia kazi. So kwa electronic ignition systems, ECU ndio inafanyia kazi. Okay, so the ECU plays a very important role in this case in determining which spark plug fires according to the firing order. Okay, so this one is designed to ignite the air fuel mixture in internal combustion engines using electronic components rather than mechanical ones. So ile ingine si muliona ilikuwa na nini kama contact breaker points, for instance, in the capacitors. So here ina contact breaker points and the capacitors, iko tuna ignition coil and then the distributor. And then the rest of the work is controlled by the ECU directly. So this one is more efficient and more reliable, and also less maintenance requirements compared to the contact breakers. So anywhere kuna moving parts kama contact breakers, the capacitors, they can easily wear off with time. Now, so this one inatumia the position sensors, basically. So the position sensors will inform when to fire, because it is the position of the piston that will determine whether the cam opens or closes the valves. And it is also the same rotation of the crankshaft, which is connected to the camshaft, that also determines when the distributor sends or completes the circuit so that the spark plug is ignited at any given point. So basically the ECU processes all the sensor information in order to determine what we call the firing order. Okay, so for this one, it is not about now the cam rotating in order to operate the contact breaker. Okay, in this case, it's just the position sensors. The position sensors will determine when a spark plug is supposed to fire. For example, you know that in the cylinders, usually around 20 degrees before TDC is when the spark plug ignites the air fuel mixture. Now, but in this case now, unajua the position now of the crankshaft will inform the ECU of the position of the piston. Why? Because the piston and the crankshaft are connected together through the connecting rod. All right. So it sort of just uses the ECU and sensor information to determine when to fire. Okay. So that's how it controls the ignition system. So you can see it can suddenly, so the sudden collapse. So we've been talking about the collapse of the magnetic field so that it induces high voltage or more in the secondary winding. So that high voltage voltage is delivered to the spark plug, jumping the gap and creating a spark. Now, so anyway, so this one is just about the lighting system. We really don't need to talk much about it, but kwa lighting systems kuna kwangana different lighting systems. So we don't really go deep into lighting system, but you know that kwa lighting systems kuna kwangana low beam na high beam. Ile tunaitanga dim and what? Tunaitanga dim and full lights. Okay. Pia kuna zile daylight running lights. Okay. These ones usually turn on when there is poor visibility on the road. For example, looking kwenye kuna fog. Sometimes kuna konga na daylight running lights. Just kando kwa headlights. You'll see them coming on just to improve visibility when it is there is heavy fog or there is excessive humidity or there is too much rain. Okay, when it is raining so much. Pia kuna fog lights zinakonga pale chini kwa bumper. Those ones mark the position of the vehicle relative to the ground. Okay, na wewe inasaidiananga sana kwa kukumulikia pale chini kwenye uwezi. Unajua headlights zinamulikanga pale mbele, but you need fog lights kukumulika pale chini next to you so that you can even see bumps, for example, in a case where you have very poor visibility. Okay, kuna zile indicator lights, brake lights. Indicator lights ni zile za kuturn, you are turning, una indicate. Brake lights, you will always see the brake lights coming on even if it's daytime when you engage the reverse gear. Oh, sorry. No. Brake lights will always come on when you press the brake pedal. Hata kama ni mchana, you'll always see them inakuwa ni red. So just improve visibility and it tells the driver that is behind that the car in front is decelerating. Tail lights, they will always come on as long as the headlights are on. So tail lights huwezi ukaziona mchana, but ukifungua, ukiwasha zile taa za mbele, the headlights, tail lights pia zitawaka. So the tail lights will mark the boundary of the car and the rear section. Okay, so kama tail light moja tuseme for example haifanyi, then the person behind hawezi akajua na kama anaona gari ama nduthi. Inaweza kuwa ni pikipiki iko mbele because anaona tu only one tail light. So inakuwa very dangerous to have only one tail light functional. So it's always good to ensure that they are properly maintained. Okay, so exterior lighting kuna kwa pia na reverse lights. Reverse lights, ukiweka tu reverse gear, reverse lights will always come on, whether ni mchana ama ni usiku. Why? Kwa sababu hata mchana, the moment you see reverse lights na zinakuwa very bright, you'll know that car is reversing. So kama ulikuwa umesimama nyuma hivi, inabidi maybe ujaribu kumuondokea or create space for that person. So reverse lights will always be on whether it's mchana ama ni usiku. Side marker lights ni zile zinakuwa kando ya gari, they'll always mark the boundaries of the vehicle. Then kuna zile license plate lights zile zinakuwa kwa number plate. Okay, so number plate lazima ikuwe illuminated very well, especially at night, even for example for security purposes or even for the police to notice you. Dashboard lights zinakuwa pale mbele. Okay, yeah, so mostly they are just illuminated and they will always illuminate the dash, the control panels or the infotainment systems. Dome lights, so map lights zinakuwa pale juu, they are simply for general light cabin or reading. Ambient lighting is just aesthetics. You'll see this kind of ambient lighting sometimes installed in matatus just for beauty and aesthetics, nothing much. Okay. So anyway, season I was just trying, but he utaenda tu kuiona. I was just trying to illustrate the different kinds of lighting systems. Also lighting sources, you can go and read about the kinds of bulbs that would be used. Kuna zile LEDs, kuna laser lights, zile zikuanga very bright. Mkayo kwa magari zingine inakuanga na hizi laser lights, it really blinds you. Okay, so kuna, let me take this call just a minute. Okay, sorry, I was on another call. So anyway, I will take up any kind of questions right now as I upload the next presentation. Kama kuna swali unaweza ukauliza. But I want you to go and read more widely in terms of, for example, the problems that you'd find in ignition coils and how they are dealt with. For example, is ignition coils huwa zikichapa, they are normally just replaced. You normally just replace them. Okay, spark plugs are also usually replaced, and then there's also an interval of replacing them. For example, you'll find that in some kinds of some scenarios, you'd find that the maintenance policy requires that they be replaced after every 10,000 kilometers, regardless of whether they are still working fine or not. Now, if you replace moja, I mean, if one is dysfunctional, then you always replace all of them. Always replace spark plug moja. Okay. So you normally replace all of them, especially the spark plugs. And you'd always know the spark plugs because they normally fall. You'll always see spark plugs in the electrodes. They usually become a bit dark. They're usually dark at the electrodes, and when they fail, they usually cause all those kinds of problems like misfiring, for instance. Okay. So it's always good to pay attention to the maintenance policy of, say, for example, vehicles. So, kama ni personal car, of course, it's usually recommended, depending on the type of spark plugs that are used, whatever, you could be replacing them after every maybe 10,000 or 20,000. But usually, you'd find usually the range in between 10 and 20,000 kilometers, they are supposed to be replaced. They should not go beyond that. Because also, if the spark plugs start getting worn out after some time, inaletanga problem with pure fuel economy. So even if they are still functioning well, but if they are not firing properly, then it means that at some point it's not producing the correct amount of energy that is enough to combust the air fuel mixture in the cylinder. Okay, so inaletanga poor fuel economy. And now hii ninajuanga, like sometimes unakuja nasema hii gari inaanza kutumia mafuta sana. And one of the first things that we normally do is to first of all check the ignition coils and the spark plugs. That is the first thing. And then of course, as we progress on to other things, for example, check whether there's kama kuna check engine light, you can also diagnose it, uweze kuona shida iko wapi. But mostly, one of the first aspects from my experience is that tuna checking kwanza spark plugs and see how they look like physically, just a physical check. And then after that, you can also check the condition of the ignition coils. And then from there, now you can also ask the client when was the last time they replaced them. So if there is no other fault, then you can simply just indicate that they are supposed to be changed. And also when replacing them, inakuanga ni mzuri sana upeo kuondono kutoka dealers wazuri. Okay, kuna zile zinaitwa XUK. No, X Japan. Unaona kuna zile zinauzwa second hand, but they are still in very good working condition. Sometimes inakuwa mzuri. Sometimes you also get zile mpya from duka. And if you also don't get a legit dealer, anakuzia pia vitu fake, and then after some time unapata pia zimechapa. You see your fuel economy moving from giving you 16 kilometers per liter to 11 or 9 kilometers per liter. Okay, because especially most of these vehicles these days inakupatia tu pale average fuel consumption every time unaenda, so you will see that value coming down kidogo to over time. Then you start saying, this one, there's a problem there. So especially for fuel economy, spark plugs inakuanga ni kitu kingine muhimu sana. Okay, it's very very important that you watch out for them. Now, the other problems that you'd also find ni hapa. So the alternator pia, they can also tend to overheat sometimes. Okay, they can also tend to overheat. The rotor gets worn out. Hii rotor inafikanga pia mahali imeisha. Okay, it also gets worn out over time because it's a rotating part. So if it's a rotating part, it will always be subject to wear and tear. Okay, and the way you utajua is you can test. For example, kuna a test yenye unaifanyanga kwa gari, for a battery. So you can do a battery test where you can connect a battery tester to the positive and negative terminals of a battery like that. So your battery tester, you will connect it like that, and that battery tester inakuanga na a scale. Okay, so your scale utapata kutoka hapa and then baka hapa. So on this side inakuanga ni green. Okay, green, that side. Na hii side ingine inakuanga yellow. Okay, and the other side is red. So hii ni voltage, hii graduation yote hii ni voltage. Voltage hapa, voltage. So ikiwa green, when you can test the battery when it's not charging. Gari imezimwa. Check the voltage of the battery. Voltage usually should vary between 11.5 to 12 volts. Okay, when it is in a good condition. Na utaona hiyo nini itakupeleka hapa kwa green, hiyo arm. Kama ni zile analog ones. Okay, itakupeleka pale kwa green. Digital one itakuonyesha with an indicator that it's green. It's in a good working condition. Okay, the analog one you'll just see it moving to the voltage. Juu kutoka hapa utapata ni from around 11 volts. Okay, while kutoka hapa is usually around 8. Na hii ingine inakuanga from around 5. So ikiwa above 11 itakuwa ni green, it's fine. Okay, so when it's not charging, it should be around 11.5 to 12 volts when it's not charging. Now, ukiwasha gari, so the next thing is you also switch on the car and again do the battery testing, because kuna na button una press for like 5 seconds, and then when it's charging now, the voltage kwa yenye nafaa ionyeshe hiyo arm itasonga mpaka somewhere hapa. So itaonyesha kitu kama 14 ama 14.5. So you will now know the state of the battery when it's charging. So ikiwa 14.5 inamaanisha the alternator is producing the right amount of voltage, iko sawa. Now, if for example umepress hivyo and then you can check and then alternator the battery test inakuonyesha the alternator is supplying 17 volts, that is overcharging. And that one will damage your battery haraka sana. So that is overcharging. Now, say now we go back to where it's not charging. Okay, we call it a discharge condition. Na hiyo arm ikuje hapa between 8 and 11. Usually that would be the region of yellow. Okay, the region of yellow. So that yellow, it means that not so good, but itakupea a few more kilometers, but you should try to replace the battery. Okay, na ikiwa red, hiyo imeisha. Ikikujanga red, na nilikuwa nimesema kama ni hizo vitu za start stop, especially hizo za start stop, the moment hata inaingia yellow, sometimes hata engine inaanza kutukuleta error peke yake. haiwezi ngojea hata ufike red. Okay, so that is normally what happens. So you have to do the battery tester would give you the condition of the battery when it's discharging, that is when it's not functional, when it's under discharge condition, and also when it's charging. So when it's charging, nimesema inafaa kwa 14.5. So for example, if you press the alternator, if you press the button when you're doing the testing, and this arm goes to between 11 and, same for example, 10 volts, that alternator is not producing the right voltage to charge the battery. So ikikuja tu maybe 11, 9, inamaanisha alternator is faulty. Hii alternator iko na shida. Na sana kwa hii alternator, hii ndio inakuwa ni culprit, the rotor. Okay, either the rotor ama the stator, one of those two, because those are the moving parts. Unajua culprit zinakuanga first of all kwa any mechanism are the moving parts, because hizo ndio zinakuwa na wear. Okay, those ones are the ones with the most wear. So those are usually the two culprits. So unaweza ukaifungua, you can check the condition, but in most cases, if there is when you do repeated tests over different periods of time, you realize that it's giving you that constant low voltage or an overcharging, then it's important to do the correct repair and maintenance procedure. So the alternator, you can replace the stator. So those are things that could replace single moja unaifungua. So you have specialists wenye wataifungua and then they replace. In some cases, if it's an extreme scenario where it's basically gone, so because sometimes pia inaweza kwa you were involved in maybe an incident where it received a direct mechanical hit. So inafika msa zingine pia maybe iligongwa, maybe ulikuwa na car accident or something like that, God forbid, ikagongwa and then ikapata some direct mechanical hit. Then in some cases it's even hard to salvage it. In most cases you'll just replace it with another one. But it can malfunction for several reasons, not just mechanical but also electrical problems. So any electrical component, it can fail for so many reasons. And the easiest way to know is by doing a battery test. Both when it is discharging, tutajua kama battery iko na shida, and when it is charging, to know the condition of the alternator. Okay, it's very easy. So I think hiyo mbili nimemaliza. See kama kuna mtu kuna swali, and then we can go to the next. So if you have a question, you can press your microphone, you can ask, ama uende direct kwa nini, or you can type as I move to the next slide. So you can ask, can give you like 2 minutes to ask a question before we go to the next slide, that is a suspension system. Okay, so now we go to the suspension system. So here in the suspension system, you know the function of the suspension system, and I'm just going to go through it. I just try to mention the key and important things in the suspension system. So you already kuna notes, but I just want to bring another aspect of suspension system that probably unaweza kuwa hujaifikiria before about the suspension system. Okay, so nataka kwanza nianze kwa kusema hivi that suspension system iko na, so I just want to mention so suspension system, kitu ya kwanza is that kazi yake, a lot of people think that the suspension system is to absorb vibrations from the road. I mean, most people think that is its primary, okay, it's its primary function, but it's only major function. Okay, so we always say like the suspension system, if this is, for example, this here is what you call a 2DOF system. 2DOF is a 2 degree of freedom system, where hapa uko na body is where you have the chassis and plus passenger, chassis plus passenger. Even the what I represent in what you call a 2DOF. Okay, so I think you probably have done what you call the free body diagrams. So these are free body diagram. Na hapa kuna spring. Spring ni ile inaweza kuwa ni coil spring, McPherson strut ama leaf spring. Okay? Damper ni ile watu wanaitanga shock absorber. I don't know why they call it a shock absorber, but yes, they call it a shock absorber. Now those ones, hapa pia kuna tire. Okay, you can see there's a tire and then the surface. So hapa chini is the road surface, hii ingine hii. Okay, uneven road surface. So as the tire moves across an uneven road surface, same for example imeenda ikapita kabump hivyo like that. That is the surface. So same ikifika hapa for example at this point here, you'll see the tire being displaced upwards. Itaenda juu kidogo, right? Na ikienda juu, the body here, so unajua pia body hapa itakuwa na some displacement. I can call it a displacement of x meters upwards. That is the chassis. Wewe mwenye umekaa hapo ndani, si utasukumwa juu, gari ikipita bumps wewe pia utarushwa kidogo. Lakini the work of the spring is to absorb that motion, that displacement. Instead of you being displaced, it is the spring that should be displaced. Okay, should be displaced. So that you're not supposed to be displaced upwards. It's the spring that should be displaced. However, you will find that the spring will not absorb all the energy from the displacement of the tire. Okay? It will not absorb all the energy. Why? Because it is not designed to absorb all the energy. In any case, even if it works as an energy absorption system, it will not absorb all the energy. Some of it will spill out and it will be transferred through the chassis to the body and to the driver. Ule mtu mwenye amekaa pale, wewe sasa mwenye unakaa hapo unaendesha gari. Okay? So, you will find that its work is to absorb. We actually say to attenuate. That is usually the word. Attenuate road vibrations or vibrations due to uneven road surface. So it attenuates, so it absorbs iso vibrations from the uneven road surface. Instead of you feeling it, it's the one that is supposed to absorb it. So that is the work of a spring. So ukiona a spring in a suspension system, ujue kazi yake ni kuabsorb that. Now, the other function is to also create some clearance between the road and the body or the chassis. So take the body and the chassis as the same thing. The body and the chassis and the passenger equal the same thing. Now, so ina create your clearance. That's why unapata watu wakinunua gari, kuna watu unasikianga wanasema nataka kuinua gari. Kuinua gari ni nini? Kuinua gari is simply to increase. So one thing you should know is this, that his spring iko na kitu inaitwa spring stiffness. Now spring stiffness is measured in newtons per meter. Now, if say for example that stiffness of that spring is 5,000, okay, 5,000 newtons per meter. Inamaanisha hiyo spring, it needs a force of 5,000 newtons to compress it by 1 meter. Because it's a coil spring, so it acts through compression, right? So inamaanisha inahitaji a force of 5,000 newtons to compress it by 1 meter. Any force less than 5,000 will not compress it by 1 meter. Maybe it end up to 800 meters only. And then inakwama. So it means therefore that if you have a higher spring stiffness, for example, umeenda ulinunua springs, na hiyo springs ulinunua ilikuwa na spring stiffness ya 5,000. Can you now imagine if unakuja una replace those springs na za 10,000 newtons per meter? What will happen? Inamaanisha you will require more force to compress it by 1 meter, which means that they will resist more the application of force in the body. Hiyo ni load sasa. You, the passengers, the cargo and everything. So inamaanisha you will now need more force to compress it by 1 meter because of the higher spring stiffness. So ukisikinga mtu anasema naenda kuweka heavy duty springs ama nataka kuinua gari, basically they are going for higher stiffness springs. So just so that they can be able to do what? To increase the resistance to the application of force. So utajaza hiyo gari with the same load yenye ulikuwa naika before, but utapata gari bado imebaki kama it's compressed but very lightly. Okay, so that clearance on the road sometimes is desirable, especially in the cases where, for example, the car is new and you are driving it across rugged terrains and you want to utake gari yako ikuwe na kwaruzwa bumps pale chini na mawe na nini vitu kama hizo. Mnajua hizi mashida za magari za nyumbani, the roads za huko nyumbani. So but now the thing is, hiyo time ukiinua gari ujue ina raising the COG, utapata COG imeenda hapo juu. So previously utapata maybe ilikuwa hapa chini, then the moment you raise it, COG inaenda pale juu. So it increases the roll tendency of the car to roll. Okay, roll axis ni hii. So if this is the car, this is front, hapa ni mahali driver ako. This is the front wheel, this is the front right, this is the right wheel, this is the left. Hapa tu ni mbele ya gari, hii gari na kuface. So the tendency of the car to roll to the side this way, we call it a roll axis. So when I increase the tendency of the car to roll, okay, and increase the tendency of the car to roll kwa sababu you've raised the COG. So anytime you raise the COG, then there are high chances that that vehicle will roll. Okay, that is inakuanga ni shida kubwa sana. It's usually a very, very big problem. Now the other thing with suspension system is this. Now I want you to imagine that you are moving forward at a speed. Ulikuwa naenda, hii ni gari yako. Okay, this is your vehicle. And then you have your vehicle and all that. Now, when you are moving forward and you apply brakes was inashika the wheel hapa. It resists the movement of the wheels. Now, from Newton's first law of motion, kuna kitu inaitwa inertia. Inertia is the tendency of a body to continue moving forward, even when acted upon by an external force. So if you were running, for example, and you hit somebody, chances are mtaendelea pamoja kwenye wewe ulikuwa unaenda because of inertia. So in the same way, even when you apply the brakes, haimaanishi hiyo gari itasimama hivyo haraka. Because of inertia and it was moving forward, it will continue slightly moving forward. So now, the work of the suspension system is because it is elastic. You can see that it is elastic. Okay, because of the damper and that. So, unajua, ukishika hizi miguu, if you apply the brakes to the tire, like that. Inamaanisha, there is no rigid, because you can see here that there is no rigid connection between the vehicle or the body and the tire. So if the tires are not moving because you have applied the brakes, then there will be a tendency of the body to continue moving forward, because remember, the body and the tire are not rigidly connected together. Had they been rigidly connected together, for example, the body and the tire are fixed directly on the chassis, hakuna suspension system, itakuwa inamaanisha that anytime unakanyageo gari, especially kama an emergency braking system, huyu mtu amekaa hapa, okay, that passenger will tend to move forward kidogo. Why? Kwa sababu gari imesimama, but there is still inertia in that car. That inertia will push the passenger forward. That's why zingine unaambiwa lazima uko na safety belt. Kwa sababu gani? Yeah, sudden braking. Sometimes the whole system is not able to absorb the energy. Now, so let me explain this. Now, the suspension system, because of the fact that it is not a rigid connection between the body and the car, when you apply the brakes, you have the person who is seated here, the passenger, amekaa hapa. Now, it is the body that will move forward slightly because of, so the suspension system will swing forward kidogo tu. It will swing forward a little above the axis. Of course, it's fixed here. It is fixed here, okay, and also fixed here. So even the suspension system will swing forward kidogo tu, so that you do not move, you as a passenger do not move instead. So they are sacrificial. They are the ones that absorb the inertial energy, okay, or the energy from the motion, the kinetic energy from the moving car when you apply the brake suddenly instead of you. So the body will move as well as the suspension system. So it will swing forward kidogo tu. Okay? So So haifai kukua rigid, because ikikuwa rigid wewe ndio utatoka. But of course when there is an excessive sudden braking, then you'll feel the effects. That's why unaambiwa pia uvae safety belt for such cases where there is a violent stop. For example, unaweza kwa maybe you hit say a stationary object for instance. Ama maybe ulikuwa unaenda hivi, ng'ombe ikatokelezea mbele yako, ukakanyaga hizo brakes kabisa. So kitu inakusaidia ni safety belt, because the safety belt will retain you in your seat. Okay, instead of you moving forward. That's why inakuwa ni mzuri kuvaa safety belt. Now, so all I'm saying is that is the work of the suspension system, to move forward and allow for braking action to be as effective as possible and to allow you to be as comfortable as possible. Kitu ingine ambayo braking system the suspension system inafanyanga ni nini? It improves the ride comfort. So by the fact that it reduces the vibrations from the road, because it's the spring system that is absorbing the vibration, it makes the ride to be comfortable. So wewe mwenyewe as a passenger utakuwa unafurahia sana ukiwa pale. That's why if you are in a high-end vehicle like an SUV, think of maybe the latest ZX Toyota Prado, Land Cruiser. You find that hiyo gari inaweza kimbia ikaenda ikapita bumps na hata wewe hata usikii ulipita bumps. But the same bumps upite na gari ndogo tuseme for example kama Suzuki Alto. By mistake umepita hizo bumps bila kuziona. My friend, utarushwa juu na chini. Why? Because the quality of the suspension system in a ZX is not the same quality of suspension in a Nissan, maybe Nissan, I don't know, Murano or which one. No. Let me, we can use something like Suzuki Alto, for instance, or some of these small cars. Okay, ama ile Subaru inaitwa aje, there's a smaller type of model of Subaru inafanyanga uba sana siku hizi. So anyway, so what I'm saying is that the quality of the suspension system determines how comfortable the ride is. That's why high-end vehicles have very, very complicated suspension systems, very complex suspension systems. And it's because SUVs are generally meant for off-road, and also they are also meant for what? For not just off-road, but they're also meant for what do you call? They are also meant for high level of comfort to the user. Okay. So that is the work of the suspension, to improve ride comfort. Okay. Now, the other one is also to support the weight of the vehicle. So you can see here the weight of the vehicle here is supported by the suspension system. And in fact, in this 2 degree of freedom system ambayo iko hapa, this is usually known as the unsprung mass. Unsprung, that is unsprung mass. From the word spring, that is the past participle. So unsprung. So the body here, sorry, we call it sprung mass. My mistake, sprung mass. Yes, it's Damien a joke, yes. Yeah, so sorry, nilikuwa namaanisha inaitwa sprung mass. This one here is sprung mass. Sprung mass, okay? So sprung mass is because it's suspended by the spring here. So whenever we model suspension systems, now tuna modeling na kitu kama SolidWorks. Sorry, tuna modeling na kitu kama MATLAB Simulink. For instance, we always model the body as a sprung mass, and we always take the body as a single mass, one mass. That is you, the cargo, and the chassis. Yote inakuanga ni lumped mass. Okay, in vehicle dynamics, we call it the lumped mass approach. Okay, we call it the lumped mass approach. All right. So the lumped mass approach is where you take the whole mass to be one. That's why hapa imeitwa the body, and then you have the spring. Now, what about the damper? Then what is the work of the damper in this case? Now, people say that the damper is a shock absorbing unit, but I think, in my opinion, most of the shocks are absorbed by road shocks are absorbed by the spring. However, there are also shocks from the spring itself. Now, think of a scenario where this spring, assuming you can a lot of force na ukaigonga with a very high force, you will see it vibrating. It will vibrate kabisa ile, okay? You see it vibrating like that. Okay? So that kind of vibration will be the same kind of vibration you'll see if the vehicle passes across a bump suddenly, ama a pothole. It will vibrate, which means that you know the way it's a coiled spring. It's a spring. Think of a small spring hata ugonganisha hivi, utaona tu ikivibrate yenyewe. Now, once you pass over a bump, the spring will not stop vibrating immediately. If anything, it will vibrate like that because it vibrates as a sine wave. So over time, the vibration reduces. That is, the amplitude of the vibrations will reduce over time. Okay? So the time taken from the start of the vibrations back at the end, okay, is a time t. Now, but it is not desirable to have these vibrations continuing long after umeshapita bump, because maybe ilikuwa tu ni bump alafu ukaendelea na a very smooth surface of a road. So there is need to ensure that these vibrations stop almost immediately after you pass the bump. Lazima upunguze hiyo time. So from time 1 to time 2. So how do you minimize the vibration of the spring itself after you pass across the bump? Because it absorbs that energy, but it will attempt to dissipate energy by continuing to vibrate. Because remember, the energy from the road, that is the uneven road surface, umeigonga hiyo bump, the spring itself ndio ilichukua hiyo energy. But that energy will not stay in the spring. It must be dissipated somewhere. You know from the conservation of energy, that is the first law of thermodynamics. Hiyo energy lazima iende mahali. So does it dump it? It will dump it by continuing to vibrate, but with less and less amplitude over time. All right? Now, but you want to minimize also the time it will dump. So you want to ensure that it will dump that energy very fast. So what do? You add a damper. That is why the name is a damper, not a shock absorber. So when you call it a shock absorber, I feel always, from person who studied vehicle dynamics for a very long time, I think it's a wrong term. Because it is not a shock absorber. What kind of shocks are we talking about? Unless you are specifying that there is a shock absorbing unit for the spring, not for the tire. Okay? Anyway, I stand to be corrected, but just my opinion. I think that the correct word is a damper because it has a damping coefficient. Okay? So it will damp the oscillations of the spring. That is why I call a damper. It will damp the oscillations of the spring. That is, it will enable the oscillations to decay faster because the decay process is such that it reduces the amplitude of successive vibrations. Okay? Now, how does it damp? Damping is basically an energy absorption process as well. So it absorbs energy from the vibrating spring kwa sababu ndani ya hiyo damper iko na hydraulic fluid. So the hydraulic fluid will now absorb that energy. Okay? And then it will convert it into pressure. It will convert it into pressure energy and also heat energy. Okay? So it will now also move back and forth, and then it allows the spring to stabilize as soon as possible. But also, you must know that it will also take away some of the energy from the uneven road surface. So its work is not exclusively to damp the vibration of the spring, but it will also to some extent, because of the fact that it's a single unit, most of the time inakuanga a single unit, the spring damper system inakuanga almost a single unit. So somehow, yes, it could absorb some of the energy that is the damping, that is the damper is taking, can be sometimes directly from the tire. But most of it, because of the way it is connected to the spring, almost 90 or 80 to 90% is from the spring. That is the suspension system. That is how it works. Na hiyo ndio kazi yake. Okay, that is how they work. Now, kuna kwanga na different types of suspension systems. So kuna kwanga na zile tunaitanga passive. For example, kama hii ambayo unaiona hapa, tunaita passive suspension. Unajua ni kwa nini? Kwa sababu for the damper and the spring to work, it must be in contact with the uneven road surface. Now, but kuna ingine inaitwa semi-active suspension system. Hii damping coefficient ya damper, because si tumesema kwa spring compressive load and heat energy. Yes, compressive load and heat energy. Yes. Now, so mimi nasema damping. So damper, the characteristic of the damper is that iko na kitu inaitwa damping coefficient. Na damping coefficient inakuwa measured in Newton seconds per meter. Okay? So damper coefficient inakuanga ni C. Okay? C, and it's measured in Newton seconds per meter. While for the spring, iko na kitu inaitwa stiffness. Na stiffness inakuwa measured in newtons per meter. Okay? So spring stiffness inakuwa ni newtons per meter. Okay? So, you can determine the force output of the damper in the spring and compare it with the force output from the body. For example, for the spring, you can determine, for example, here body, when it is displaced, it is in X meters. So if you multiply spring stiffness, that is newtons per meter, and you multiply by the displacement of the body, utapata nini? Displacement is in newtons. Okay, somebody just type spring stiffness, newtons per meter multiplied by the displacement, that is meters. So utapata newtons, right? If you multiply the two, that is a force output. So because the stiffness of the spring minimizes the displacement of the body, that is how it works as a suspension system. In a reduce, instead of the body moving upwards, that is together with you, it is the spring itself that moves instead of the body. So the length of the motion in which it has moved instead of the body is given in terms of what? Meters. So if you multiply the spring stiffness and the displacement of the body, then unapata nini? Utapata newtons, which is a force. So it basically felt as a force, the work of the spring. Now the same thing, the work of the damper is also felt as a force. You know why? Kwa sababu the damper is multiplied by x dot. X dot ni nini? X dot is the, when we differentiate x, that is now the displacement, tunapata nini? Velocity. So velocity inapeanwa in meters per second. So if you multiply the damper coefficient, which is Newton seconds per meter, multiplied by meters per second, bado utapata force. You can do that. You can confirm it. Newton seconds per meter, that is the damper coefficient, multiplied by the velocity of the body, because the body will also move upwards in a certain velocity, of which it is usually absorbed by the damper as well, by minimizing minimizing the oscillations of the spring. So it also reduces the velocity, the rate at which the body is moving forward relative to time. So, which means it also has a force output. Now, what about the body? Tutajuaje force yake? So, for the body now, tunaweza further differentiate velocity. Tukidifferentiate further velocity, tuko na x dot. X dot is acceleration. Acceleration inapeanwa in what? So, you know nini is acceleration. But you know something. From Newton's second law of motion, if this body has a mass m, na hii acceleration ni, so Ex dot is acceleration. I know from Newton's second law of motion that F equals to m, which is this ambayo nimewapatia hapa na a. Which means even for the body, it is still felt as a force. Okay? So which means there are three forces here. Kuna force due to the body, force due to this, and also a force due to that. All those forces must cancel each other effectively for the suspension system to work. Right? So, tunafaa kwa ile force ya body, that is the force of the body, acha niandike hapo, should be equivalent to the force due to the spring plus the force due to the damper. Okay? So the force due to the damper and the spring must cancel out the force of the body, so that this works as a spring. I mean, this works as a suspension system. Sasa hiyo ndio kazi ya suspension system. Okay? I just wanted you to look at it from a different angle, not just ina-absorb. Yes, ni nini ina-absorb? What is it? It is cancelling out those forces. Alright? It's cancelling out those forces. So that's what you must understand when you talk about the suspension system. It is cancelling out the forces. So the work of the spring and damper system is basically just to negate whatever is happening to the body. Of course, it's not 100%. That's why you'd still feel some of the forces. But if the suspension system is designed like the high-end suspension system, you almost do not even feel And I'm talking about, for example, if you're taking a ride in some of these very high-end vehicles, for instance. That's why saa zingine hizi magari unaonanga hizi kubwa kubwa, I mean kama nini, for example the ZX or even the G-Wagon for instance. Hiyo gari itakuja kupita zile rumble strips, hata hakuna kitu utasikia. Wewe utapita na alto yako, even rumble strips peke yake utasikia ni kama umerushwa juu. But hizi zingine hata zile bumps kubwa saa zingine unaona tu zinakuja zinapita. They don't slow down so much. But Google mtu si ataisikia sana. So that's why the suspension system must always be kept in a very good condition, good working condition for you to be able to feel as comfortable as possible. That is why when the suspension system is worn out, some of the parts are worn out. For example, if you have the springs, for example, develop cracks, the damper is totally worn out. Ukipita hata kabump kadogo hivi, you feel as if ni kama uko kwa mkokoteni. Okay? So that is some of the issues that you get. So kwa hii ingine semi-active unapata iko na the damping coefficient. Kwa hii ya kwanza hii ni constant. Hii ingine ya kwanza. Damping coefficient is a characteristic of the type of fluid that is inside there and the pressure under which the fluid is kept. Lakini kwa hii ingine damping coefficient can be varied. For example, unapata kama hii ni damper. So damper iko na 2 channels where you can add oil inside, you can add oil on one side or take it away in order to vary the damping coefficient. Kwa hii ingine, hii damper zingine za kawaida, zile ambazo the shock absorber za kawaida, unaona it has a fixed amount of oil inside or hydraulic fluid, hydraulic oil. So inamaanisha damping coefficient yake ni moja tu. Of course it will reduce over time as the parts where, for example, the piston nini vitu kama hizo, or there is a leakage. But for this, there are other types of dampers ambazo utapata the damping coefficient is controllable or it's changeable. You can vary the damping coefficient depending on the road conditions. So utapata if you are moving on a rough, on a very nice terrain, for example, it's a city road, then the damping coefficient can be as low as possible because you are not having a lot of problems. I mean, it's a very smooth ride. But if you go off-road, you will see that it will pump in. So it's inakuanga na a pump, okay, that is usually activated by the ECU that adds the amount of oil inside the damper. So the damping, the pressure inside the damper, okay, it will usually be of a higher value, which means that it will improve its damping coefficient. So kuna kwanga na certain types of dampers ambazo they have variable damping coefficient, and we call those types of suspension systems semi-active suspension systems, while those ones that are ordinaries ambazo tunazionanga magari zetu mingi ziko nazo tunazita passive suspension systems. Na pia kuna zingine zinaitwa active suspension systems. Okay? Now active suspension systems inakuanga na an extra, sometimes you have you have a spring and instead of the damper uko na an actuator. For example, a linear actuator. I don't know kama iko hapa. Yes, this one here. So kama hii, for example, this one here is an active suspension system. Na unajua ni kwa nini? You can see here kuna spring, right? Na hapa kuna damper. Now, and then on top of that, uko na a motor. You can see this one is an F, it's a force. So you have a motor. So the motor will always, kuna sensor hapa, sensor ina measure the position of the MS. That is the sprung mass. Nimesema sprung mass is the mass which is the body, the chassis, that is the chassis, the cargo, and the passenger. The whole of that is taken as a single mass, right? I think tuko sawa hapo. So the displacement of that body, kuna sensor itakuwa ina sense this displacement. And then pia kuna unsprung mass, ile nyumbani nilikuwa nimesema. Na nilisema unsprung mass ina contain the wheel. Na unajua wheel iko na nini? Iko na, for example, the tire. The wheel consists of the tire, attachment to suspension, iko na lower control arm, the lower part of the, or attachment to control, attachment to lower control arm, arm. What else? It will also have the rim, okay, etc. So hizo part zote tunaitanga the wheel. So tukisema wheel, wheel is not the tire only. Yes, the tire is part of the wheel, but all those components, you have the tire itself, the rim, the attachment to the lower control arm, the attachment to the suspension, all those parts tunaita nini? The wheel. So the wheel tunaita unsprung mass. So The work of this kind of suspension system is that the sensors in a measure the displacement of two things. One is the displacement of the MS and the displacement of the unsprung mass, which is MU. And then inazi compare. If there is excessive displacement, say for example, umeenda kwa gonga bump yenye ni kubwa without you knowing it, then that sudden change, the change in the displacement of the sprung mass and the unsprung mass, that is the wheel as well as the body, will be so big. And in that case, the controller will send a signal to the motor, and the motor will adjust the what we call the suspension working space. Unaona hii hapa. It will adjust it upwards so that instead of you moving up, it is the suspension system that adjusts to absorb the energy that would have pushed you upwards. So it's the suspension system that adjusts itself using a motor. So usually inakuanga either a motor or an actuator. So kuna kuanga mingi sana. So unaweza pata kuna motors, kuna actuators nini that do that work. Okay? So these ones are called active suspension systems. Na hizi sasa ni high-end suspension systems. Okay? These ones are high-end suspension systems basically. Now, so tunaendelea. So tumesema so pia kuna kitu hapa ambayo nataka tu kumention. Hii KT ni nini? Hii KT, remember these are free body diagram. This is not representing the real parts. These are just nini. So KT is the stiffness of the tire. Do you know why we say that the tire has a stiffness or behaves as a spring? Ni kwa sababu it's made of rubber na iko na air ndani. So inamaanisha the tire also has a level of stiffness. It behaves like a spring. So unajua vile spring inakaa. So the tire also behaves as a spring. So that's why ukiona hii iko na K. That is stiffness of the spring. Hii tunaitanga KS. Na hii pia hii ingine tunaita KT ambayo iko hapa KT, which is the stiffness of the tire. So there are two stiffness here. The stiffness of the spring itself and that of the tire. Because as long as the tire is made of rubber, it is elastic. It has air inside. Then it also absorbs. So in fact, some of the impact from the road is also absorbed by the tire. That's why tire lazima haiwezi ikakuwa solid. Na ndio maana kuna kuangana recommended pressure kwa gari, kwa mguu ya gari. Most of the time utapata they recommend for most passenger cars, the sedans, saloons, wanasemanga 35 psi, that is pounds per square inch. I don't know how many bars that is, like 1.6 bars. So 35 psi pounds per square inch. Okay? So kwa sababu ukipitisha sema instead uweke 60 psi, then the tire imejaa, it behaves as if it's very rigid. So inamaanisha instead of absorbing or being elastic, it is rigid side that it's transferring the forces, or that is now we say that like the vibrations, the vibrations from the ground to the suspension system. And when the suspension system is overworked, because even the tire is not absorbing some of them, then some of it, well, most of it will be transferred to you. That is why inakuwa very uncomfortable ukijazanga tire. Hata kwa baiskeli, I'm sure most of you started riding bikes. Ulikuwa ukipata ile mguu ya mbele ukijaza pressure, ukienda upite kwa mawe hivi unaona inaruka juu. Kwa sababu gani? It is very rigid. So inafaa kwa say that it is elastic, unafaa kumuza hiyo pressure ndio tire yenyewe ina move also elastic and absorbing the terrain, the rough terrain also. So hutaifeel sana. So it will also be doing the work of absorption. So which means that it's also elastic, it's behaving as a spring. The same work that the spring does is the same work that the tire does. That's why it's made of rubber, and the rubber also must be of good quality. Okay, so that's just why I wanted to bring to your attention. Now, pia unaona city here. Okay, the tire also has a level of damping coefficient kwa sababu ya hewa iko ndani. So we pia tuna model, and then we also assume that ile air iko ndani also behaves as a damper somehow. Okay, so iko na some level of damping coefficient because of the air. All right. Now, another thing that I also want to put it to you, ladies and gentlemen, is that kuna kuangana certain types of actuators that are placed there in order to do energy harvesting. So unaona, for example, badala ya hii damper ya kawaida hii, unakuja unaweka spring. This is the normal spring kama hii. Okay, so that is the normal spring. Alafu sasa badala ya hii damper hii, the ordinary damper, unaweka another special type of damper. which is actually an actuator. So hii damper kwa some high-end cars or for military applications, especially zile zinakuanga za military application, unapata actuator yake is a special type of an actuator. Yenye it moves up and down, and as it moves up and down, doing the work of a damper, an ordinary work, it is constantly converting the mechanical energy from the reciprocating motion of the damper and then converting it into electrical energy. Okay, so it converts the mechanical energy from the reciprocating. Remember, damper inakuanga na piston pale ndani, so it captures the displacement of the piston up and down in as form of mechanical energy, and then it's used to operate a very small generator, okay, which is part of this energy harvesting module iko hapa. And then it is taken to a charge management module. So the charge management module iko na inverter ndani, because remember the power that is produced here inakuanga ni nini? AC. All right, so the charge module will then direct it to a battery pack, and then it will be stored there. So utapata sana kwa military applications, okay, because it's just an energy recovery method, ndio maybe they can get extra power to power certain communication systems. Unajua mkiwa pale kwa vita kuna wana certain special communication systems that need to be powered. And if you continually drain that power from the battery, sometimes it also strains the engine and all that. So whenever they want to also expand, even in terms of energy access, or even charging some other power modules, or for example communication systems, utapata ziko na vitu kama hizi. Okay, so they are there. In fact, when I was working in my laboratory way back when I was doing my MSc, one of my lab mates was doing a project on walikuwa natumia backpacks. They were touching them with some energy harvesting modules. So sazile unatembea, you know the backpack moves up and down. Okay, it will always be moving up and down. So ina capture that motion of up and down movement. Okay, and then ilikuwa ina convert that energy. Ilikuwa na very hapo tu kwa shoulders, kwa hizo straps za shoulders, iko na an energy harvesting module that it's a small generator that generates power, and then ina store kwa power bank ambayo iko ndani ya hiyo bag. So I later came to know that they were actually for military applications. Juu unaonanga watu wale wanaendanga, say for example, wale wanaendanga wako Boni Forest pale, wanaenda wanafanyia kazi ya military work and all that. Most of the time they're operating in off-grid places, mahali hakuna stima. So saa zile huyu jamaa anatembea na kubeba hizo mizigo zake, ana generate power, and that power ina charge power bank na wanatumia kupower their communication systems. See, you know that communication is also very important in military applications as well. So I later come to know that they were actually doing it for the government of the country that I was in, and they were doing a very high level research, very highly funded. And I realized that it was some of these kinds of research sometimes that you should also be applying. And they were also doing some research to convert some energy. I don't know what the material they were calling. This material, when you stress it, it produces electricity. Is it quartz or nini? I don't know. So they were placing on the soles of feet. I mean, katikati ya soli ya kiatu. So soja akitembea hivi, that continual stress, it also generates some energy. Is it quartz or nini? I don't know. You guys tell me. I think so. I think it's quartz. So that stress, that mechanical stress pia ina generate electricity, and that electricity ilikuwa inakuwa channeled also to the backpack, and then it's stored in a power bank. Na pia wanazitumia for use, wanacharge even their own phones, the communication systems. So most of the time unapata wanatumia hizi satellite phones and all that, they would be using to power them and all that, sending signals, etc. Okay, so all I'm saying is this, that you can capture this energy. So you can capture this energy and use it to basically to power other things, and the suspension system is simply one of those that you can capture that energy. So I know you already know about the fact of I just wanted to give you a different way of looking at the suspension system than what you would ordinarily think of it. Okay, there is so much that the suspension system can do other than what you just know. Now coil springs inakuanga hivi. So coil springs, so generally coil springs, so when you see it ikiwekwa hivi tunaitanga the McPherson strut. I don't know whether this iko hapa. We normally call it the McPherson strut. So with the McPherson strut, you can see here, hii part inaitwa the steering knuckle. Okay, that is the steering knuckle. Yeah, steering knuckle. Okay, so as part of the steering knuckle assembly, it's connected to the wheel. There's wheel hub fixture, iko hapa. And then you have the spring itself. And then inside is the damper. Damper ndio ile iko ndani pale. And then the strut mounting. And then this is the lower control arm. So lower control arm ndio una connect the chassis from there. Okay, so from here you have the chassis, inaenda to the chassis. All right. So when replacing, for example, this spring, inakuanga ni rahisi sana. Hapa juu kuna kuanga na a nut that fastens the damper to the spring. Okay. So usually when it comes to replacement, because sometimes you want to do replacement for one reason or the other. Maybe you want to inspect the functionality of the damper. Because sometimes unapata damper imeanza kuleak. Okay? When the damper starts leaking the hydraulic fluid inside, if you see any form of leakage around the damper, then it's supposed to be inspected properly. And in most cases, once it starts leaking, it means that it will not function as intended. Most of the time, it just be replaced. You just replace it completely. Unanunua tu ingine. Okay? So kitu ya kwanza when doing any kind of service on this is that unaekanga G-clamps. Unakuanga na G-clamps unachukua, na hizo G-clamps inashika hizo springs. Remember, these coil springs act through compression. So you have to compress them to allow you kufungua hapa juu. Juu kunakuanga na nut hapa juu. Huwezi ukaifungua if the compressive force of the spring is pressing on it. So lazima uchukue some type of a G-clamp and then you clamp it. But I've seen in some jua kali wanatumianga kamba. Sijui kama umeiona, wanafunganga kamba. There's a way wanafunga kamba and then wanaeka kamti pale and then wanaizungusha hiyo mti. So continually it compresses the spring. So, but I feel like it's dangerous. I mean, if you have clamps, you can just use the clamps. Okay? So ukishafungua pale juu mahali kuna hiyo nut, then you can now disassemble the whole of these parts. So unatoanga the whole of this top part of the strut mounting, and then you will be able to now isolate the spring from the damper. Now, but ujue pia saa zile unaitoanisha kwa gari, I mean hata nimeruka kidogo. When removing it, of course lazima kwanza utoe mguu. Unajua mguu inakuanga hapa. Okay, so si lazima utatoa hii mguu hapa. Okay, so you have to first of all remove the wheel, or basically the wheel assembly. Okay, once umetoa hiyo wheel assembly, then you can be able to now access it in this form. Itakuwa inakaa hivi. So lazima kwanza ufunguanishe, kuna two bolts, hii na hii. Okay, so on this side it's a bolt, and then on the other side, kutoka hii side kuna nut. Okay, so lazima ukwe na, most of the time when you're being trained would be having two of them, like one fixed and another one that is the fixed jaw spanner. Kuna kwa na zile the fixed spanners, then kuna zile the ring spanners. So ring spanner ndio unatumia kuifungua. That is, the ring spanner is placed on the side of the nut, while the fixed spanner is placed on the side of the bolts. Okay, that is here. Ulikuwa naiweka hapa. So ulikuwa na tunaweka the ring spanner here, while on the left hand side unaweka the fixed spanner, and then unaifungua, because both of them, otherwise ukizungusha hivi utakuwa unapata zinazunguka pamoja. So you have to sort of hold it in place unless you are tightening it, but kama unaifungua you have to hold one stationary ndio ingine iweze kuzunguka. That's how you disassemble it. So once you disassemble it, like I said, pia unafungua hii, and then but first of all you must clamp the springs together. So you clamp the springs together, and then once you clamp the springs together, sasa unafungua these two nuts, so these two bolts, you loosen the nuts on the other side, and then pia there's also another bolt up here. Okay, once you disassemble all of them, now you can check the condition of the springs. Okay, so you can check the condition of the spring. For example, one of the things that you look out for is if this spring iko na cracks. Sometimes unapata wrong somewhere hapa iko na cracks. Anytime you may develop crack, those springs must be replaced. Okay, kuna watu zingine unasikia nasema you can weld it, you don't. Okay, and it's always important to look out for unapata some of these springs zinauzwa pale. Kuna kwanga na watu wanafanyanga ujanja. Unapata it's an old spring ilikuwa imetumika, but wanaendanga wanapiga, inakuwa very round vizuri, wanapiga hivi na wanaweka tu kwa anvil and hammer, wanaigongesha, wanailainisha, inakuwa very round, alafu wanapaka rangi ya black. Wewe unakuja as an unsuspecting client unainunua. Few days it is working fine. The next unaona gari imeanza tena kurudi chini. Shangaa nini imehappen, juu ulinunua springs fake. So it's always good to know the suppliers where you are buying from. Always buy very legit springs, because they are expensive as well. One could be as high as 2,500, and you always buy as a pair. Unajua kama ni ya front left, kama ni front left iko na shida, you also have to replace the front right. Always replace the two of them. Okay, especially kama ni za mbele, because you know the front wheels are used for steering, so they are very, very sensitive to any imbalance. Because if one spring is good and the other one is not good, it means there's an imbalance in the wheels. Okay, in terms of the forces, that is the forces, the steering forces, it's very hard to balance them when the suspension system is faulty. So unazinunuanga pamoja at the same time. Okay, so lazima una replace as a pair. So that means you must always buy with a good a very good dealer. Now, so hii ndio nilikuwa nasema. So I was saying that hapa kuna kuanga na nut when you are disassembling this. Kuna kuanga na nut. So lazima kwanza uziclamp hizi springs hapa ndio iweze kufungua hii nut. Otherwise ukifungua hii nut na hizi springs are not clamped, itafungwa na force nyingine iko juu sana na inaweza ngoa men. So you have to first of all clamp and then ufungue hapa. These studs hizi tatu, you will see these studs being mounted on under the hood. Ukifungua gari pale utaona kuna kwanga na nuts. Usually zinakuanga ni tatu. Okay, usually zinakuanga ni tatu zinatokelezea pale juu. So this part here, the top part which I'm showing you, these studs here, is the part where you fasten it to the chassis of the car. And it is usually under the hood. Ukifungua pale bonnet kwa mbele utaziona those three nuts. Usually inafunganishwa hapo. Okay, usually on either side of the front of the hood. Okay, on the either side of the hood. So when disassembling it, kitu ya kwanza, like nimesema, unatoanga mguu, you remove the wheel, the whole wheel assembly, and then once you may remove the wheel assemblies, you go for these two nuts. Hizi ziko hapa. Okay, once you've done that, you can now unfasten the nuts that are fastened to these studs or the bolts. Once you've done that, then unatoa the whole of this unit inakuja chini. Yote unatoa inakuja chini. And then after that, like I said, you can now clamp this and then sasa ufungue hii nut. Ukishafungua hiyo nut unatoanisha yote. It's very easy to do it. I mean, if you have the right tools, it's very easy. You don't even need anyone to tell you what to do. So hata kama sasa zile una replace na uko na the right tools, you can replace it yourself, because you know how you do it. If for example you've inspected and you find that there's a crack here and you're supposed to replace both of them, all you need is to jack the car and then you remove it. Unaitoa. It's very easy to remove it if you know what you're doing. You don't even need any external support. It's things you can do it by yourself. And then after that, you can take the sample. Kama hii ndio sample unapeleka pale kwenye unanunua. I always insist that it's always good to go with a sample, so that at least whoever is selling it to you akona an idea in terms of the length of the spring. So because kuna kwanga na kitu inaitwa the length of the spring. So kuna hii ni length. Unaona hii total hii inaitwa the length of the spring. Alafu kutoka hapa hadi hapa, we call it the diameter of the coil. Hii ni diameter of the coil. Okay? There is also another diameter here, which I don't know whether you are aware of. You see this small one here? We call that the diameter of the wire diameter. Okay, wire diameter. Now, it's very important, by the way, especially when also replacing, because those are the things that affect the stiffness of the spring. So the stiffness of the spring is a function of wire diameter, ambayo nimeonyesha, the coil diameter, which is from here to here, the length of the spring. There's also the pitch of the spring. Pitch ni kutoka hapa hadi hapa. That is the pitch of the spring. So all those things can be varied to get different stiffness. So hata saa zile una design, because right now there's even a project I'm working on, and part of the work that we were doing was to design the coil springs for that system. So tuko tuna design wenyewe, tunapata standard dimensions, and then tunatumia kwa mtu mwenye anatufanyia manufacturing, anaenda anatengeneza exactly what you want. Okay, even for my MEC project, part of the work that we were doing was to develop new types of suspension systems, and some of the things that we were installing even in test vehicles, for instance, would be these kinds of springs. So tulikuwa tunakatu chini because they are design calculations you can do. Unapata maybe, for example, you have limited space, so you can minimize the length of the spring but increase the wire diameter. You can still have a smaller diameter wire, but with a larger stiffness. You know why? Because the length is long, because maybe the spring is long. But you can also have a shorter length spring. It is very short, but the pitch is more. You have a more pitch. It can still have the same stiffness as a longer length spring, by simply playing around with the diameter, the pitch, the wire diameter, pitch, length, as well as the coil diameter. And even the number of these coils, the number of these coil number 1, coil number 2, coil number 3, coil number 4. So the number of coils also influence also the stiffness. So you can play around with some of these parameters in order to have the correct stiffness. Because, for example, as I calculate that I need a spring that has a stiffness of 8,000 newtons per meter. You simply design that. And then unapeana inatengenezwa na itatengenezwa, and also the material, by the way, also the material also influences the stiffness of this spring. Okay, pia it also influences the stiffness of this spring. So anyway, so all I'm saying is that you always check for cracks. Some of the things that you always look out for is you check out for things like cracks, for instance. When it comes to the damper, nimesema kwa damper unatafuta nini? I don't know whether nimeweka damper hapa. I don't know whether the damper is here. I'll see kama damper iko hapa. But the damper inakuanga na, like I said, one of the signs that it is worn out, kuna kuanga na leakage kwa damper. Kukianza tu kuwa na leakage, ujue probably there is either the piston is worn out, because the piston usually moves up and down, or the seals. Pia kuna kuanga na seal pale ndani, because ina contain hydraulic fluid ndani. So hizo seals pia zikikuwa worn out, in most cases you'll just have to replace. Na vile nimesema, kama ni za miguu za mbele, front right damper is worn out. When you're replacing it, you replace both the front right and front left damper, even if the front left damper is still in a almost good working condition, so that you have equal damping coefficient at the front wheels. So usually uzi vitu unazi replace in pairs, uweze ku replace moja. Now, so we move on. Now, kuna hii kitu inaitwa leaf spring. So leaf spring suspension is also another type. You will know how they function. I will not talk about it. I just want to mention something. Now, kwa leaf springs, unaona hizi bushing. Bush here is usually made of rubber. Okay? Inakuanga ni rubber, because kwa hii bush, you normally have a bolt and a nut that is used to fasten it to the chassis. So chassis iko hapa. Okay? That is a chassis. So, when fastening it to the chassis, you normally have inside this bush, kwa hii bush, you normally have a bolt that goes through that bushing. Na kwa sababu the bolt is made of a metallic component, na pia hii leaf, we call it a leaf, is also made of metal. If you have two metallic parts contacting each other and moving relative to each other, then there will be a lot of friction energy and a lot of noise. So to prevent that relative motion between the leaf itself as well as the bolt that fastens it to the chassis, lazima uko na bush hapo. So your bush ni kitu inakuanga worn out. It gets worn out over time. So it's some of the parts that you look out for when replacing it. So it's some of the things that you always have to replace it. Now, hapa pia kuna kuanga na another eye hapa nyuma, inakuanga an eye. So that eye also pia iko na bush hapo ndani. But there's also something interesting at the back. Kuna kitu inaitwa shackle here. So shackle is, so between hii bush nimesema hapa uko na chassis hapa. Okay? Na hapa pia kuna chassis. So ukiona hii leaf, the rear eye and the front eye are not both connected directly to the front eye, which is this one, is connected, or it provides a connection directly, of the spring to the chassis. Lakini kwa rear eye, hakuna direct connection of that rear eye to the chassis. It is through another mechanism. It's a very small mechanism that looks as if it has nothing to do, but I'll explain what it does. So, kazi ya shackle ni hii. You see here, that is a chassis. Okay. Now, what happens when you move, because hapa kwa bolt, kuna kuanga na U-bolt hapa, by the way. Kuna kuanga na kitu inaitwa U-bolt hapa. A U-bolts and then the axle. So, in the axle ya gari inakuanga hapa. So, inamaanisha the wheel inakujanga hapa. It's normally assembled here. So, kuna a U-bolt that now hangs the suspension itself to the axle ya mguu. And then the axle fitted to the wheel. So when you are moving forward, alafu kanyaga brake, unakanyaga nini? You resist the movement of the wheel. The wheel is rotating. So when you resist the movement of the wheel, remember kwa chassis hapa ndio kuna ile body. Remember now the free body diagram. This is the body of the car. Now, the body will tend to continue moving forward kwa sababu ya inertia. Now, because you also want to minimize the rate at which the body moves forward, is displaced forward when you apply the braking force, you want the suspension system to swing slightly forward and absorb some of that inertia instead of you, who is part of the body, moving forward when you apply the brakes. Okay? So, the shackle here, unaona hapa, it provides for a swinging action because it is a pivot point between the chassis, which is here, or the body, and the leaves. So at this point becomes a pivot point to allow the spring to swing forward when you encounter or you apply braking action. Because a braking action inasimamisha the rotation of the wheel. But because of inertia, I've said that the body will tend to move forward slightly. And now this is the work of the suspension spring, which I started with. Hiyo ndio kitu ya kwanza nilikuwa nimesema. Okay? So the shackle does that exact work. For the McPherson strut, you do not need a shackle. Unajua ni kwa nini? Kwa sababu the action is longitudinal. If you see this one. Unaona this one? It will be fixed here and it will be fixed here. Okay, you can see that it is fixed here. So it will swing forward. It will swing forward kidogo tu. Itaenda mbele kidogo. So it does not need a shackle because it can swing forward longitudinally. Okay, it can swing, vertically. Okay, in that vertical position, it swings forward and comes back. So it does not need a shackle. However, for a leaf spring, it acts longitudinally. That is along the length of the vehicle. Hivi. So because of that, then you need a swinging action. So hiyo ndio inakuwa ni kazi yake. Now, leaf springs, how maintenance yake, the top one tunamesema inaitwangwa the main leaf, and then the rest are just called companion leaves, the rest of them. So when you are checking for, maintenance inakuanga to check the condition of the leaves. Sometimes unapata along the leaf, this is the width of the leaf, kunakuanga pia na crack for one reason or the other. So kukidevelop hizo cracks, then that leaf has to be replaced. Usiwahi kubali na kuna watu wanasemanga, oh, you weld it, but you do not weld it. You simply replace it. Because then it will lose the stiffness. It will not behave as a spring. Okay? So that is how it's normally done. Now, so the other thing that you do is you also check, like I said, the condition of the shackle. Also, the shackle also gets worn out over time because there's a lot of general relative movement along the pivot point at the rear eye. So sometimes it also gets worn out. And sometimes not just that, even the bolts and the nuts, sometimes they just need to be replaced. So always check the condition of the nuts and the bolts. There's also another center bolt here that holds all these leaves together. Okay? It's called, so you always also check for the condition of that bolt. Because of the stresses, sometimes it cracks. They also need to be replaced. Pia kuna kuanga na a strap hapa. Unaona hii kitu hii, kuna kuanga na hizi straps zinakuanga hapa. They are called ribbon clips or straps. So those parts sometimes they become loose over time. So they are supposed to be fitted correctly. Sometimes also replaced when need be. So those are some of the things that you would watch out for. Now, so let's move. So that is the work. Now that is the work of the lift spring. This is the shackle. That is how it swings. So you can see this is the chassis. This is the frame of the body, and you can see how it's fitted. So at this point, the leaf is not connected direct to the body, but rather through the shackle to allow for that swinging action, which I talked about. Now, kuna other types of suspension system. For example, this one is called the double wishbone. So double wishbone, ikona two jaws. They are called wishbones. Hii ya juu na ile ya chini. Ile ya chini is part of the lower control arm. So it's like two control arms basically. And those two arms swing about a pivot point. Hapa juu it swings about hapo, na ingine ina swing about hapo. So they swing back and forth just like you would find them in leaf springs. Okay? Or even in just like they would find them in coil springs. So double wishbone suspensions they just aid the process of just function as an ordinary suspension system because it simply swings back and forth about two pivot points. So this is the upper wishbone, hii ambayo unaiona hapa, while this one here is called the lower wishbone. And those two wishbones are pivoted about a point, hapa na hapa. So they swing back and forth. That back and forth swinging is basically working as if it's a spring as well. Those are how double wishbone suspensions work. Now, double wishbone, you should also know the advantages, and I'm telling you to know what are the advantages of double wishbone, say for example, over leaf springs. Okay. Advantages of double wishbone over leaf spring suspension. So kitu ya kwanza utaona ni space requirements. You can see leaf springs inahitaji a lot of space. You can see they require to run the whole of this length, inachukua space sana. Okay? Well, double wishbones unaona they occupy a much smaller space. So in terms of also space economy and all that. Okay? So I want you to go and read about what are the advantages and disadvantages. Pia iko na disadvantages zake. Look at, for example, the complexity of these features. Okay, so you also have to look at maybe the complexity in terms of ease of maintenance. So sana when you're thinking of what are the advantages, you look at the complexity of the features, ease of maintenance, okay, and then economy of space. Those are the two main things that you'd always look out for, in addition to others. Kuna cost factors. Here you also have to look at the cost factors. All right. Now, kuna ingine inaitwa trailing arm suspension. So the trailing arm, it is more or less like that. But the trailing arm, you have the coil like that, and then here you have an arm. We call it a trailing arm. So in a trailing arm, it is pivoted in the same way as the wishbone suspension, the lower part of the wishbone suspension here. Ni kama hiyo tu, hakuna tofauti kubwa na the lower wishbone, that is the lower part of the double wishbone. But now the difference is that it is facing backwards. It is like twisting this arm, instead of it facing inside the chassis, it is facing backwards. Okay? And it will still do the same work as a double wishbone, except that it is only one wishbone, which in this case is a specially designed wishbone known as a trailing arm. Okay, so trailing arm inakaa hivi. So you can see, for example, gari inaenda pale mbele. This is the front of the car. So this is the damper, this is the spring, and then you can see this a low control arm. Kwa ile ingine the control arm ilikuwa ina face inward, but on this one it is facing backward, and then it kuna two pivot points, and you can see here at the back the two pivot points ni hii na hii. So it will still allow for that swinging action, and at the same time also working as a suspension system. Why? Because nilisha explain the suspension system kazi yake ni nini? To displace itself or to be displaced instead of the body. So because it is pivoted at those 2 points, it will be swinging back and forth, enabling it to be displaced instead of the body, therefore improving the ride comfort. So it will still work as a suspension. Now in this case, for example, unaona zinatumika pamoja. So imaanishi ukitumia double wishbone uwezi ama trailing arm uwezi ukatumia spring and damper. So mostly utapata this type is utatumia kwa heavy commercial vehicles or heavy trucks, buses. Kwa sababu gani? Kwa sababu kuna there is the issue of like weight. How much weight are we dealing with? An ordinary dumper and spring will not support the whole of that weight and dump all the acceleration coming from the road. So you need a way of simply aiding it. So you'll also, most of the time, utaona this kind of trailing arm suspension in vehicles. In vehicles such as, for example, trucks, pickups, certain heavy commercial vehicles, especially those that are more than 3.5 tons. Okay, utaziona some of these trailing arm suspension systems. Now, so I've talked about the three of them. So nimesema kuna McPherson strut, double wishbone na trailing arms in a hivyo. So you can go and make a comparison and see what it's all about. Now hydraulic damper ndio hii. Nilikuwa nimesema kwa hydraulic damper, this is how it works like. That is, hii sasa ndio ile shock absorber. So hydraulic damper iko na fluid inside, you can see. Na pia inakuanga na a gas, okay, which is also a working fluid, and all of them work to dump the oscillations off. Like I said, primary function, dump the oscillations of the spring, as well as also absorb some of the vibrations from the rod. Okay. Now is it dampers? In terms of, you can go and read how it works. I think niliongeza kwa notes. I'm not very sure. If not, you can go and read about it. But generally, how do you normally check out for, well, in terms of service and maintenance? So this, for service and maintenance, usually one of the easiest way to know, like I said, is check for leakages. But in case you don't get any leakages and you feel that your suspension system is starting to become stiffer and stiffer, what you can do is this. You can go and, once you disassemble it, the way nilikuwa nimesema before, you disassemble it from the, if it's a McPherson strut, you place it on the ground, hii particle ground, and then you compress the top part. Okay, you compress the top part, and then you observe how fast it regains its original displacement or its original height. So unaifinya, alafu unaona how fast it comes back. Now, when the hydraulic fluid is still in a very good working condition, it's not yet worn out, because the hydraulic fluid pia inafika mahali it's not decomposing. What is the word? It breaks down. So it breaks down. The chemical components used to make it break down. So, and also the pistons, pia sometimes they also they get worn out. So if it's still in a very good working condition, first of all, you will need a lot of force F to compress it. Inakuwa ina resist that force sana. Huwezi ukaipush. That one is a very good one. Hata uhitaji kufanya a lot of tests. Now, but if you apply that compressive force, na inaenda all the way, kuna zingine zinaenda all the way mpaka unasikia kama umefika chini kabisa. So that one means that the fluid, the hydraulic fluid is totally broken down. That's number one. The seals are gone kabisa. So inaenda chini, and then you will also see that it takes a long time for it to regain its height. Inarudi pole pole. It will almost take like 5 minutes for it to rudi juu. But when it's in a good working condition, even not in a like perfect working condition, not like 100% new, if it's still like 90% good, even if you compress it, it will allow itself to be compressed slightly. But when you withdraw that force, utaona inarudi back haraka, which means that they is still in a very good working condition. Those are some of the ways you can also test it, other than also manually checking for any signs of leakages on the condition of the seals. Those are hydraulic dampers. So you can also go and check more about how they function. So these are some of the many types of hydraulic dampers. Kuna different types kulingana na application na kazi yake na gari. Okay, so zinakuanga mingi sana. There are so many types of hydraulic dampers that are in use. So like I said, kama hii for example, you place it down hapo, and then una press this piston. So this one here is a piston. You press it and see how fast it regains its original shape. Hivyo tu, inakuanga ni simple sana. That's one of the ways. Or you check for signs of leakages, especially around hapa. Hapa kumekuanga na asili. Okay? So zile seals zikisha utaona fluid ina leak. Okay? So those are some of the ways to simply check out for it. Okay? Kuna kitu pia inaitwa anti-roll bar. So anti-roll bar, you'll also see them in suspension systems. So anti-roll bar inakuanga ni such that it is fixed above these points and also fixed above this point. So anti-roll bar is such that if, for example, hii mguu is on a very nice or a smooth terrain, lakini ingine imepitia kamlima, so that the wheel ime raise kidogo. So when that wheel raises, remember this part here of the anti-roll bar is still fixed, while the other part is raised. So because of the way it is made, it will resist the twisting action. It will attempt to force this wheel to the ground. That action force of resisting twisting, because it acts as a spring. So it will be twisted upwards by the rotating, by the wheel that has gone through an raised terrain. The other wheel bado iko sawa, but one wheel is raised. So it will resist that twisting action, and it will attempt to force that wheel which has been raised back to the ground. By resisting that force, it is forcing that wheel to remain on the ground, thereby improving the traction of that wheel. So in a resistasa, the rolling action, because like I said, if this is a front left car, this is the left, this is the right hand side. If the car were to rotate from the right hand side moving to the left hand side, we call it rolling. Your gari may roll. So for example, you can see here that if one wheel is raised hapa, then the twist, it resists the twisting action by forcing the wheel downwards. So it sort of forces the wheel to remain on the ground. That's why we call it an anti-roll bar, and it's part of the suspension system. So it improves the roll characteristics of the vehicle. Na inakuanga ni very important, inakuanga kwa gari. This is something that you can be able to see. Okay? The other one is called the torsion bar. So torsion bar runs longitudinally. Sasa ingine, this is the anti-roll bar, while this other one runs along hivi. So it's also fixed hapa na hapa. So this one resists twisting action. Okay, so it's because it's fixed at the front and the back and front. If this wheel were to be raised, same for example, imepitia terrain ya juu. Okay, so for example, if both of them same imepitia terrain ya juu na zile miguu za nyuma iko terrain iko chini. Okay, maybe iko ni kamlima. So somehow, because of the fact that it is fixed here and here, it will resist the twisting action, because that raising of the front wheels in either way will twist it out of position. If it is twisted out of position, it will produce an equal and opposite reaction to that twisting force, therefore reversing the effects of that twisting. So if the twisting action is caused by the wheels moving upwards, it will twist it backwards down, so that it retains those wheels on the ground. So it is just a way of improving traction of the wheels, so that the wheels are always on the ground, regardless of the terrain. Na utapata inatumikanga kwa most of the cars. You'll see them mostly in things like trucks, for example, in commercial vehicles. They play a very important role, because the roll and pitch tendency in this kind of vehicles inakuanga very high, because COG inakuanga ni juu. So in the COG's due, you have to ensure that there is sufficient traction on the ground. So that is the work of the torsion bars. You can go and read more about them. Pia kuna kuanga na air suspension systems. So air suspension is inaitwa air springs. Okay? So you can see these ones, for example, instead of, so hii iko na hewa ndani and then iko na rubber. It's made of rubber. So it is, remember like I said before, a tire, as long as it's made of rubber na iko na air ndani, then it will behave as a spring. You remember that I said that in the start of the class. So which means you can now have specially made rubbers, and then you have air inside, so that they behave as a spring, and they will be as efficient as any other spring that you can see. Okay? And they are in use, in common use. So I want, and you utaona kama, for example, hizi buses za Basico. Ukiona hizi za the electric buses, hizi za Basico, zinakuanga na air suspension. So if you get a chance one day to maybe visit Basico, make sure that you go under the hood and also check the air suspensions, how they look like. But they look like this, hizo nimeonyesha. So iko na advantages zake na disadvantages compared to the airs, the leaf springs and the others that you've talked about. Okay, so you can see here air suspension. This is how it works. Okay, so the air suspension, like I said, it simply works in the concept of having or using compressed air that is supplied by a system like this. So I wanted to go and read more about the air suspension, how they work, and how they are maintained. What are the maintenance requirements? So those are the things that I'm telling you to go and do. So number one, okay, so take these as self-check questions. How do air suspension work? That is number one. Something, what is happening here? Okay. Okay, so how do air suspensions work? Okay, I want you to compare and contrast. Okay, both in terms of advantages and disadvantages. Advantages, so functionality, but in terms of functionality, advantages, disadvantages. Compare and contrast. Double wishbone, trailing arm, McPherson, leaf, and air suspension. So like compare and contrast. What are the advantages of one over the other? For example, we talk about air suspensions. What are the advantages? What makes them good enough or special enough to be used? Okay, why are they? Would they be preferred in certain scenarios? Na kwa magari ndogo huwezi ukazitumia. Okay, so those are some of the things I want you to look at. So for example, how do they work? Okay, na kuna image ambayo nimewekea hapo, but I want you to go and read more just to, it's also always good to also leave you to also do part of it, because I've done most of the explanation for the last 3 hours. So I want you to also make sure that you try and go and compare them in terms of their functionality, advantages, disadvantages for the double wishbone and trailing arm. So first of all, you can compare double wishbone, trailing arm, and then leaf and spring. Okay, I think I should have done that. And then from there also compare, for example, air suspension and things like the trailing arm as well as the double wishbone, and then you can ask. But I'm still here for, I'm giving you like 1 or 2 minutes. So I don't see any questions, so which means I assume that the explanations that I've given are sufficient. So make sure you supplement the knowledge that I've given you by reading more widely, look at the notes, and ensure that umeelewa everything, because I've mentioned so many things that are not in the notes. So most of that nilikuwa tu just kuongeza and give you, because I usually just don't want to read the notes. It's always good to also give you a different perspective, especially for the suspension system, especially in terms of their functionality and applications, especially even for things like military applications, which I just mentioned. So that will be it for today. We meet next week on Friday. Tutaongea na class rep how we can schedule a cut, because we need to do two cuts na assignment. So for the assignment, there's a way I will structure the assignments. These ones I'll be giving them as questions as the class is going on. So kutakuwa na class yenye tutafanya yenye kutakuwa na maswali. So I think I could decide maybe tunaweza fanya kama next week Friday. So I will see how we can structure the assignments. But assignments nitakuwa nawapatia during class and then mnazijibu hapo kama inaweza kuwa ni swali na nini. So I think it could be next week, and then from there we can talk about how we can do a cut, because you also need to do 2 cuts. Okay. Yeah, so I think, but the good thing is that I think we are moving on at a good speed. So next week we should be able to cover much more ground. But mimi nimemaliza. You guys have a very good weekend, and then let's meet next week Friday.